I wanted to turn the lights on, but it's a lost cause. I have one light over here, but I don't want it shining in my face. It's kind of obnoxious. No, it's really bright. Anyway, I guess we can get going. Yeah, unfortunately, with all the smoke, I don't know what we're going to see with this on, but
That's okay. I think it's enough.
Yeah.
Anyways, the recommendation is to turn off the camera when you're not speaking. So
Yeah. So it'll only
we'll
be on
just
for a couple of minutes. Can't get the mic to work. Well, you have like, I don't know, 3 hours or something.
yeah, 4 hours. With
I was talking to Alistair. So, Alistair, if you can't figure out your mic, I don't know. It's too early to do computer stuff. Anyway, so this is the Risc-V micro conference. I think it's time. Yeah, it's time to start the introduction. So yeah, Risc-V micro conference. It's kind of regular Plumbers micro conference stuff. We're here to talk about stuff. So got a bunch of discussion leaders, and we'll try to have like Atish was saying earlier, video on only when you're talking in order to prevent bogging everything down. That's really the extent of it. I didn't have anything particular planned for the introduction, just kind of getting everything going. So I don't know if anyone has anything. If not, we can hang out for a couple of minutes and let Al figure out how to get the presenter mode going. Oh yeah, I'd recommend testing all of the presenter stuff during like the break before your talk or something like that. It works, but I couldn't figure it out the first time. So I said I am sitting here in the dark because I also can't figure out how to turn on my lights. So, hey, I guess maybe not the best example of what to do.
okay, I'll
hang on a second.
I'll change the presenter mode. Give the presenter mode to Al.
Yeah.
Okay,
I think like
done.
some people seem to be able to take presenter mode. I don't know who's capable of doing it.
I think it should be you and me. Anybody who is the moderator of the MC. So. No, everybody should be able to take the presenter mode.
Yeah.
Oh, I don't know.
So I think we found out during the Android one that everybody has a lot of permissions, and if you click the wrong button, it will break stuff for other people. So don't click the wrong button.
And I think for us, never click the no. Oh, there is another button.
Don't click the like end meeting button because that will end
button. Yeah. But I don't see that meeting. I think
I'm gonna drop off here and let Al go.
Nice rocket, Al.
Oh, thank you, sir. Okay, so that's not the right slides for me. Yeah, that's that Lego set, which was just way too much fun.
Sorry, I tried to grab whatever you had uploaded to the web.
Oh, no worries.
Should I switch the slides?
Yeah, because it looks. I mean, I can see Palmer's schedule slides, but I don't see mine yet.
Okay, let me take the.
Yeah, they're all uploaded. I guess maybe we should switch the slides between presenters, Atish, because it's
that's better.
Yeah.
Okay.
Let's do it that way.
And I just marked them downloaded, so it should be up. I will transfer the presenter mode to you.
Yeah, so you should be able to go through the slides on your own now at the bottom.
Okay. Try go. You able to control them?
Oh, look at that. Yeah.
Awesome.
Perfect. Thanks, guys. Shall we officially wait 1 minute or?
Yeah, I think with all the internet stuff, it's best to just stick strictly to the schedule.
Yeah. Yeah, so as it turns out, Atish, I have an uncle that was part of the Apollo program. So he and I talk about these sorts of fun things all the time.
Nice. Yeah.
And I can't wait to go through his boxes of stuff in his garage. Well, I have 5 after. Shall we go?
Yeah, I'll be showing these, so just don't freak out if my face appears when the time is up. So
no, I love how high tech those are. Is the cool thing.
Yeah. Okay. I think you're good to go. Right on time.
Okay. Well, this will be interesting. We'll see if I have enough coffee in me and those sorts of fun things. So, so Risc-V is an interesting platform, obviously. We're all here. That's kind of makes it obvious. But I think one of the things that that I've been very interested in is how do we actually make this move it from an interesting toy into something that quite literally could compete with the likes of Intel in the data center, for example. The idea of having more variety and more heterogeneity in the instruction space or in the ISA space is just, I love that idea. You know, the idea of everything being built on top of Intel, I think is just, I don't think it's healthy for the industry as a whole. So when we look at Risc-V, though, how do we get from what it is to something really, really useful? And you know, the ISA is really just a small part of the product. There's all the other things that need to be defined on the SoC, how to talk to the SoC, you know, what buses it connects to, et cetera, and so forth. And there's just a large number of them. So really, in the long term, what I would like to see with Risc-V is that it just becomes absolutely dead boring. I can pick up an OS off the shelf, I can install it, and it's just like any other box, right? And what I think needs to happen is to do that. We kind of need a clear vision for what needs to be specified. We need a process for making that specification, and we need a clear and complete specification. So if you're familiar with the ARM space, that's referred to as SBSA and SBBR. I think what we need is something very clearly like that. I would even like to take that a step further, though, and say that's great for servers, but I think one of the things that we could do to make Risc-V more robust than the ARM environment is to actually make those specifications useful across a broad range of use cases, not just servers, but possibly embedded systems, IoT, whatever it might be. So that's kind of where I'm going with all of this. So here's just sort of the overall agenda. You know, what am I talking about when I say the vision thing? You know, in what I think should actually be in some sort of specification, how we can go about getting things done, how do we fill in all of the blanks? So, you know, we do have a little bit of material for a platform specification, but what do we need to really fill that out? And then I would like to invite folks in for even further discussion on the content and what do we need to specify, what do we need to leave alone, where are the boundaries for those sorts of things. Okay. So for those not familiar with American politics, the vision thing is a phrase borrowed from George H.W. Bush, and he got roundly criticized for it because it sounded very vague and silly, but in a way it is. But what I'm trying to say here is, where are we going with all of this, and what would I like to see happen out of this? And to be fair, I'm approaching this from the standpoint of I guess I didn't make that clear at the beginning. I work on Red Hat Enterprise Linux. I'm in the platform enablement group. And what I'm interested in is those things that make my life easy. As we all know, it's all about me. But the key thing is, how do we make it so that distributions like RHEL, like Ubuntu, like SUSE, like name your favorite poison. How can we make sure that all of those things work just kind of out of the box? So that's really sort of the vision. And when I started looking at what we have is something called the Unix class platform specification. And my first sort of reaction to that was, well, that's kind of too boring. Because I think about general world domination with Risc-V. And if I think about that, how do we support the various, the BSDs, the different RTOSs? And it would be nice at some point if we could actually get around to even supporting Windows. So, think about, if you will, a world where I go down to the local shop and I can buy a Risc-V laptop, an Intel laptop, AMD, ARM, you name it. That's the kind of world I would like to see, and that kind of variety in the different ISAs available. So my first suggestion and first thought was, well, let's make it an OS platform spec, so it's not just Unix, although that covers a broad range of things. Let's make sure that we can deal with all the other needs of all the different OSs and various forms of distributions like BSDs. Okay. And the second thought was, well, really, what's the key goal in all of this? And really, it's to set the expectations for what is provided to me as the distro provider. What can I expect to see, and how can I expect it to be described, and how can I expect it to be used by the OS, as well as to tell the platform providers sort of what they need to provide. So, if you will, a contract between the distros and the platform providers, so that we can all get along easily, and so we all know what to expect of each other. And really, we just need to get to the point where it's, I buy a Risc-V server, I plug it into my rack, I boot it in, and we're done, right? That's how simple it really needs to be. So that's kind of the first thought. So let's take this idea of an operating system platform spec a little further. One of the things that I've seen in the past, I was very heavily involved in the ARM side of these things many years ago. We need to clearly define terminology. So, for example, one of the words that gets tossed around a lot is platform, right? What does that mean? We need to be very clear about that. And some of the things that in the specification that are a little strange are things like will and shall and should and must. English being the imprecise language that it is, it really does make a lot of sense to define those up front and make sure that everybody understands what we're talking about. But the other things, that's more of a logistics thing. The other things are things like making sure that we know explicitly which portions of the ISA are required, which are not required, but recommended, and then which are ones that we just really don't care about. An extreme example might be the 128-bit floating point. May not be worried about it today, but at some point in the future we may. But then we also need to define the rest of the platform. So the ISA is interesting, but how do I talk to it? Which buses, which devices, simple things like, what console device do I have? Am I required to have a console device? And I would say, yes, please, thank you very much. You must have a serial console. But then it's things like the buses. surprisingly, one of my pet peeves in all of this with the ARM side is here it is 2020, and we still can't get people to make PCIe correctly. Why that is, I don't know. It is frustrating at times, but that's the state of the world. Having to put quirks into the kernel as a result of that, just I'd prefer not to at this point. There's really no excuse. But that's just an example of the kinds of things I'd like to be able to very clearly say. Here's PCIe, you must do PCIe. Do not do strange things in your eCam so that we have to quirk it. And then, at least at that point we can point to the specification and say, yeah, that was a bad thing to do.
Yeah, I think the audio died. I don't know if you can hear us.
Al, I think your microphone switch on your headset just flipped.
Yeah, maybe it looks wireless. Maybe it blew up.
All your audio died. We don't hear
Yeah,
also.
I think he probably can't hear us either. Hey, Al, I'm waving. I don't know if you can hear us. Hey. Hey, look at the chat. Your audio is dead. I gotta get like a piece of paper or something here.
Yeah, I did not get one for audio died, so.
There we go.
There it is.
Hey, okay.
There we go.
Sorry about that. How long has that been gone? Sorry.
I don't know.
Probably about.
I just start waving at you.
Yeah, you just talked about how PCI just wasn't well standardized, I think.
Okay. Well, yeah, so I'll get off that soapbox for a moment. Sorry about that. There is actually a weird Fedora bug where every now and then it'll turn my microphone off, but I don't think that was it. Okay. So yes, clearly define all the required I/O, the optional I/O, what flavor it is. Let's just define a common UART that everybody has that we can talk to. But then really the key thing is just that we have a very, very clear and detailed specification of how the OS and the firmware talk to each other. And it's not for things like PCI where the devices will enumerate themselves, but it's things like where is the UART for the console? How do I talk to the other controllers on the board? Say you have a BMC of some sort. How do I talk to those that are not normally, or excuse me, that do not enumerate themselves? And additionally, that needs to be clear so that we can actually do virtualization later on, and that virtualization is possible and straightforward. But I think the key thing is it all needs to be kept simple, and it needs to be kept small. We could specify everything in the world, but that doesn't really. It constrains creativity. It constrains what we can do. So let's keep it as small as possible, and only those things that we absolutely have to have in all of this. So I'm trying to watch my time a little bit here. Okay. So the other thing that we'll need to talk about at some point is this is all well and good until we can actually prove that we've actually met the specification. So compliance will be a problem at some point in the future. If not today, even for that matter. So, the fundamental issue is you've got humans involved. So there will be mistakes made in the firmware being written, mistakes made in the implementation, but then there'll be intentional errors like my schedule is really compressed, so I'm going to take a shortcut and I'm going to do this strange thing over here. I'll just patch it over with software. It's like, no. Please, let's not do that. Because I'm the one that has to support those silly patches over time. So I think there's some things we can do to help with that, such as a reference QEMU implementation, the test suite. I don't know, at some point someone will want to talk about official certification of some sort or another. That's not something I want to deal with right away, but it will probably come up at some point in the near future. Okay, so how do we get to some sort of specification that would make some sort of sense? Well, one of the things that happened, well, I kind of was not entirely paying attention, I think, is I am now chair of the task group for the Unix platform spec. And I think one of the first things we'll probably need to do is just kind of drop the Unix part of it and just call it the platform spec. It's out there on GitHub. There's the members portal for the discussion and for other things that we'll use. But at some point we need to talk about the process, and probably this may be best on the mailing list. Is right now that seems to be the only process, is we just discuss it ad infinitum on the mailing list. At some point we'll need to get to a more formal process where we can say, here's the proposed change. It's got the proper authorization to be used as part of the specification, and that the task group itself has agreed to the change. And then it's still not clear to me how that gets verified by, say, the TSC for Risc International, Risc-V International rather. So we'll have to work out those sorts of things. Okay. Of course, there's versioning, which will be an interesting discussion. So what do we have? Well, you can see the spec that we've got there, but I'm not going to read the questions to you, but we really can't build something from the specification that exists. So we need a lot more work than that. Okay. Now there's a bunch of slides at this point that we can go through if you wish, but the basic idea here is that there is a lot of things that we need. And in particular, what we need is some structure around some of the discussion that we've already had. So there's great discussion on what to do with the PMU. There's great discussion on what to do with interrupt controllers, all those sorts of fun things, but we need to put those within some sort of framework. And this could be good or bad. I have a tendency to think from the very general to the more specific. The mailing list tends to be very, very specific. And I've still got a lot to catch up on in terms of just finding and getting in touch with all the different conversations that are currently going on about things like the interrupt controller, about things like PMUs, and make sure I understand where we are and where those actually fit into a larger overall structure. But then there needs to be some structure around all of this to begin with. And one of the thoughts is to do a more traditional structure, if you will, where we talk about the hardware, what the boot protocols are, how we do device enumeration, those sorts of things. But then as I got to thinking about this, since this was a change I was thinking about last night, was perhaps the discussion needs to be, or perhaps the specification needs to be built around the use cases and not the specific components of the hardware. So kind of turn that inside out so that maybe there's a section that says, here's what we want to do in the IoT space. Here's what we want to do for embedded systems. Here's what we want to do for general Unix platforms. Here's what we want to do for general BSD platforms, right? So those are some discussions that still need to have. We need to have as well. The other discussion I think we need to have is one that do we want to actually document what it is we have today? I'm thinking of, like, for example, the Sci-5 board. Do we want to use that as our initial level 0, for lack of anything better to call it, as an initial specification, or do we want to start someplace else? And that is a question I can't answer by myself. I think I would be inclined to say, let's go to what we want right away, just in the interest of doing things quickly, so we don't end up with a situation where the hardware is continuously leading what the specification needs to be, that there's at least an iterative process going on at that point. Instead, that the hardware and the specification are kind of working together to get to the next generation of things. So I don't know, that's to be discussed as well. Okay, so as it turns out, living in Denver, Jack Kerouac is the author of a book called On the Road, and he invented this notion called stream of consciousness. So in On the Road, that's basically what it is. It's Jack Kerouac just wrote down whatever came to mind. And if you actually see the original writing, it's all on one continuous strip of paper, which is a weird thing for a book. But at any rate, that's kind of what this list is. This is all of the things, this slide, and then probably the next one or two. Yeah, maybe. This slide is just a stream of consciousness on one afternoon where I thought, okay, what are the things that we need in order to support RHEL? And some of them are strange and unusual, like EDAC, right? This is something that is extraordinarily helpful in the HPC environment. It's not been discussed anywhere that I'm aware of at this point. Things like one of the more interesting things is machine identification. Knowing exactly what processor we're on, exactly what.
I think the audio's gone again.
We lost your audio, Al.
I assume means you can't hear us. Yeah. Someone have the paper. I didn't actually get to writing that the audio's dead.
Yep, there we go. Yep.
Sorry. I have no idea why that's happening. My apologies. So where did I lose people?
You had just mentioned, I think, just the CPU ID and started talking about it.
Okay. Yeah. So really, I think the key thing with this slide is this is just a bunch of the things that I thought of without even thinking about this very hard. That are things that need to be outlined and structured into the document in some way or another. And it's a long list. So, the machine identification one was one where that has caused us a great deal of grief in other ISAs. Not being able to tell you about the actual ISA that's been implemented on that machine. There's all sorts of things that we can do to compensate for problems with a particular ISA implementation, but we can't do that. We can't compensate for them if we don't know that that's the implementation that we're using. So fun things like that. Okay, I think I'm getting close to out of time here. So the other thought was, profiles and use cases. These, I think, are going to be kind of critical. And there's two aspects to it. One is that these are going to change over time, I assume, right? That we'll get to one level of understanding and say, okay, that was great, but we now need to improve that a little bit, and we'll do the next level. But then I think there's the key thing of what use cases involved, because I'm going to put something very different on a development board than I'm going to put on an enterprise server. And it would be nice to be able to, as an OS, predict what it is I'm going to see on each of those sorts of boards. And then the whole issue of compliance. Yeah. How do we do that? Solely by use case. What I'm suggesting is that we do it by use case and then by level within the use case. But maybe there's different ways to do that I haven't thought about. And then the last one that was weird is, do we even think about form factors? Such as mini ITX or dev boards, or do we need to clone the Raspberry Pi form factor? I don't know. That is just another random thought that occurred to me at the time. Okay. So, just a summary. I've tried to very quickly touch on the notion that if we want to get this to the point where we are competing with the likes of the Intels and the AMDs and the ARMs, then we need to have a clear vision of where we want to go and how to get there. And then, some discussion on kind of what we have, what we need, and then what happens next is really kind of why I'm here. We're going to need a lot of help. So get on the mailing list. If you're not already a member of the Risc-V International, community membership is free. Please join. And then there's a couple of different IRC channels that I'm aware of, but there's probably more. That's it. That's very quickly. Any questions at this point?
So since we are renaming it to OSPS, are we going to include? There are some discussions about the details about, let's say, running a bare metal program. So at least we can exclude those.
I'm not sure I understand the question.
So since we are expanding the scope and renaming it to OS platform spec, there are some discussion in the mailing list about what about the bare metal programs? Just run, like, boot the board and then, like, what we do on the microcontroller. Or let's say small IITs where there are no OS running. At least, can we exclude those? I'm in favor of excluding those, but.
Well, and that's a good question. I'm not sure. I mean, what does the community want to do, right? I think you could make a case that says that even those need to have some restrictions put on them, so that the developers know something about what they're getting, right? But the other case I think is that, yeah, these are, if we just view these as experiments, then yeah, put whatever you want to on it, right? But you're right. I think there does need to be room for both. And I don't have a strong feeling about specifying that sort of stuff. It seems to me that's kind of it is really kind of an experimental area, so it's not clear that it needs to have any sort of specification.
Okay,
that's just kind of my sense of it.
But also, should we define the spec for, let's say, anything that runs on them, or like Zephyr or any kind of RTOS? So does this specification should focus only on anything that boots in the S mode, have an MMU, and henceforth? Like,
yeah, that's something I've been trying to think through, because you could argue that we're not interested unless you have an MMU, right?
Yeah.
But I don't know.
I
don't know.
My fear is if we expand the scope too big, then like we just keep doing things, but actually nothing concrete come out of it, because there will be some objection to something, and then we'll just keep discussing things, but 10 years down the line, they're still discussing with platforms.
We're still discussing things, yeah.
At least the problem with the Risc-V specs is that they turn into these sort of meta specifications that try to solve everything and never get finished.
Yes.
Yeah, let's not do that.
If you expand into embedded, like really embedded, then it gets really hard, right? Because there's different embedded OS that like have different specs, right? So there's like TOC that needs an MPU, while I don't think Zephyr does. How do you draw the line there?
Yeah,
I think that's a really hard.
You also end up in the regime in which people are unwilling to pay anything for binary compatibility, right? Which is
Yeah.
kind of the opposite of what distros want.
Exactly.
I think when we first kind of partitioned out the world, we thought we'll split it up into binary compatible systems, right, which smell like Debian or Red Hat or whatever, right, and then source compatible systems, which might be an RTOS or might be even like open embedded or something like that, where you're building for one specific target.
Right. Well, and I think what I would like to do with this effort is that let's concentrate on the stuff that the distros need at this point. If we get to the point where there's enough commonality between the RTOSs, great, wonderful. We can start writing some of that down. Should we at least look at it? Yeah, but does that need to be the primary focus right away? No, I don't think so. I think my primary focus is
the right way to go.
We could have it.
Sanity.
Yeah, we could call it the distro class platform spec.
Yeah, sure.
Yeah. No, that's what I was thinking. Like have the specification, like as you mentioned, different profiles, and then one would be distro class, which at least we try to define now. And then if there are sub-task group formed for, let's say, embedded, like real pure embedded with just the M mode OSs, then they're welcome to do that. I think we are miss out.
Yeah. I was gonna
nice graphics.
I think we're running out of time.
Yeah, no, I agree. So,
any last minute thoughts, or we can switch to the next one? That would be basically a continuous discussion of this. So, I'm fine with being delayed a little bit. Okay, so I'll switch.
All right, thank you.
Thank you all. Okay. Just trying to check I'm audible and the slides are up.
Yeah, everything looks good.
Okay, awesome. So I'll start. Okay, hi. So this session wanted to discuss about what it all takes to make Risc-V EBBR compatible. So before that, just a brief introduction. I'm Atish. I work for Western Digital, and our aim is to make the ecosystem strong enough so that Risc-V becomes a dominant player. So yeah, coming back to the topic, what it actually takes to make Risc-V EBBR compatible. Before that, as all mentioned, we need the booting process, we need the entire experience to be as boring as possible. That's what the aim. And for that, we need standards. So we need to follow standards for Risc-V as well, so that it becomes dead boring and the user doesn't have to worry about learning new ways of booting OS or new ways of loading a firmware specifically for Risc-V. If you know to boot other architectures, you should be able to boot Risc-V. For that, one of the booting standard that ARM64 has followed is embedded base boot requirement. It's known as EBBR, which basically defines an interface between platform firmware and an operating system. And it's targeted towards embedded platform, but which actually capable of booting a generic OS, not like, as we discussed just in the past, not like FreeRTOS or anything, because one core aspect of EBBR is UEFI. So the reason why we want EBBR for Risc-V is make it standard, so that we use the bootloaders that already supports the specification. We use the format that already supports the specification. So you don't have to worry about trying out new firmware or new bootloaders. It's just the Risc-V bits that gets added to those bootloaders or firmwares. And then also many Linux distribution already supports EBBR, which is proven on many ARM64 platforms. So that will help us adapting to all the distros, supporting all the distros much quicker than if we go and reinvent everything from the beginning. So going to the next. So what is there in the specification? The specification that's there is basically an EBBR specification has like, if I go by the logistic requirements, it's basically hosted on the ARM software GitHub repo. The mailing list discussion happens in the Linaro group, Linaro boot architecture mailing list, and it's licensed under Creative Commons, which is very permissive. And the copyright is ARM limited contributors. So in terms of logistic requirement, as it's in community-driven document, it's not, some adjustments are required to make it a multi-arc specification, which can be worked out. But in terms of technical requirement, what we have is in the specification is a subset of UFI boot and runtime services. Most of the runtime are optional, if I remember correctly. Some of the boot time services are mandatory. So, and it mandates for the platform to use either device tree or a CPI. It doesn't have to be both, but one of them have to be supported. There you have the only architecture specific bits is the multiprocessor startup protocol, which basically defines how do you boot all the hearts into the Linux or any other operating system. I may use Linux as an example throughout the talk, but it's applicable to all other OSs such as BSD or any kind of flavor BSDs or any other OS. And lastly, the firmware storage, which basically deals with how your firmware and OS are stored in the platform. So it can be on different storage, or if it is in the same storage, then it has to be GPT partition. So all of these requirements are basically currently met by Risc-V, except one of the boot service, which is reset system, which we may need to discuss in the details. Now, so looking at the Risc-V compliance, what currently exists, there is an ongoing discussion happening in the mailing list. If you can take a look, if you have something to say, please contribute there. And we'll take a, currently we are discussing whether we can make it compatible and whether we should make it compatible. So that's the discussion happening. So please feel free to drop in. So as I said, there's already discussion happened, which led to saying Risc-V section copyrights can be added. It's the maintainers are open to accepting contributions. So we're set in terms of logistic requirements. There are some suggestion of moving the spec to the UFI org. That's not yet agreed. So I just wanted to bring up that topic now, saying if we should do it or not. Any thoughts on that? Or maybe not UFI org, any other org or any other standard specification body where it should be moved? Any thoughts from the audience?
Yeah, I'm a little. Okay, so UEFI has some very specific requirements on how material can be added into specifications. So one of the issues that has been a big problem with UEFI and ACPI over the years is that when material is added to the specification, until that specification is public, there's not supposed to be any discussion by folks that are not UEFI members. That process is changing, right? And will it change enough to be determined?
Yeah, I mean, we kind of have the same problem with the Risc-V specs, though, right? You have to be a Risc-V member, so you end up with this sort of big nest of memberships that reduces the number of people who can actually say anything.
Well,
It's probably easier to contribute through Risc-V than it is through UFI, based on our experience with UFI.
Also, I would say that given that the new process was published last week, your previous experience of that may not be applicable anymore.
Right.
But EBBR is not intended to be a UEFI spec. It is intended to be a roll-up. It's intended to be something that the OS can take and go, look, this is what the interpretation that we require in order to provide support. And it's for a very particular set of use cases, not the entire ecosystem. It's not trying to compete with the server platforms. It's trying to deal with the embedded systems. So it's roll up. It primarily focuses on UEFI, but it's not just UEFI. It actually covers a bunch of different things. So it kind of rolls up. These are the bare minimums in order to support OS out of the box. Don't have to build custom stuff, right? So in terms of moving it to UEFI, there's probably not a whole lot of value there because it's more of an interpretation document. I have no intention of actually moving it out of ARM software anytime soon, just because we're set up. We've got an issue tracker. It's got a home. ARM is happy to be the host for that. So until there's a real compelling reason to move that, that's where it's going to stay. But
yeah, thanks for
yeah, I mean, obviously, go ahead, Atish.
No, I was just saying there are two sides of discussion, so I just wanted to bring up and conclude on that. So that's good. Yeah, you can go ahead.
Yeah, I mean, obviously, to the extent that it is supposed to be something that's cross-platform rather than ARM specific, it probably makes sense to not have it, hosted at ARM in the long run.
Okay, so we'll keep that in note. So moving to the next slide. So regarding the technical requirements for Risc-V EBBR compliance, recently the full UEFI support for Risc-V Linux is available in the mailing list. I think it should be merged by the next merged window. Upstream U-boot already supports whatever the minimum UEFI required by the EBBR. EDK2 port is already in progress. So that's the link that has all the how it can be built and how you can use it. We have tested on QEMU and unleashed with all the UEFI runtime services and everything. So we are good to go, except there's one boot service that was mandatory in the EBBR, which is the reset system. So that's the only one that's not being supported in the Risc-V. Coming back to the other part of the technical requirement is the multi-process startup protocol, which is already defined in for Risc-V. It's just that we are not documented anywhere. So I guess EBBR can be the first one to document, or we'll just document it in platform spec and then refer EBBR to it, or vice versa. So the idea is to say that OS should boot only in supervisor mode. Whenever the previous stage passes the control to the OS, the A0 should contain the heart ID and A1 should contain the device tree. We should mandate, I think, SBA v02 so that we don't have to implement the legacy things again. And ordered booting via SBA HSM extension, that's what basically Linux currently supports, like the latest Linux. So we can just mandate that so that we don't have any baggage. And for the EFI to know what's the boot ID, if there is a device tree, then the boot ID property should be added under the chosen node. And for the firmware storage requirement, we are already U-boot supports and EDK2 support is already progress. So in terms of technical requirement, we are already there, except the reset system that I want to focus on the next couple of slides. So what exactly is missing is the reset system as in boot service. It's not during the runtime service, so it's not about how your Linux should actually reset. So that's an optional, so that we can deal with later. But eventually, anyways, we need a standard reset system interface for Risc-V. So currently, the boot service is being used by Grub, Pixie, EFI Cell, and the OpenBSD. The issue with the Risc-V is there is no standard reset system for Risc-V, either in privilege spec or in SBA spec. And there is no standard MMIO devices for system reset across the architecture. So the question is, does it have to be mandatory, or does it have to be, can we make it optional? So there was discussion in the mailing list, which was specified that it should be mandatory because it's an integral part of the system. But just wanted to put up that question again in case there are other. Any thoughts on can we make it optional? Is there any benefit of making it mandatory? Okay.
Yeah, I mean, I think the issue is like how, because this is kind of where we got hung up on reset the other places. Like how much do we have to specify that reset actually does stuff, and how much do we care about existing platforms where it doesn't really work quite right? I don't think it's that big of a deal.
Yeah. So the problem is if we don't make it, if we don't make it standard, these are the problems. So the first solution is then platform and hypervisor go and implement their own specific mechanism. Then all hypervisor have to emulate their own MMIO device, or let's say define their own SBI call for system reset or whatever interface they use. U-boot has config sys reset, which is already there, but EDK2 doesn't have. So that also you have to implement it, and which every platform has to override. And even after all this effort, if we don't have a standard method that actually goes to the secure monitor that runs in the M mode, there is no way to authenticate the system reset request from a non-secure OS. So these are the issues if we don't define a standard. And one solution that was proposed was define a standard through SBI call, which would basically let you, all hypervisor and supervisor can directly use it. And then you can authenticate also via secure monitor, which would be running in the M mode for any system reset request from non-secure OS. And anyways, the reset extension is optional. So if the platform wants to broaden the scope, let's say for now, SBI reset would just reset the heart and then reset the registers and then reboot again. If that's what based on the, whether it's a reset shutdown, that command, but it's anyways platform specific. Sorry, it's optional. So or do you want to say something?
Yeah, I'm struggling to understand why any of this is relevant in the context of adopting EBBR as a specification. EBBR just specifies that reset system resets the system, and
currently there is no implement.
Well, the implementation is the job of the firmware, and if there's no standardized way, then for every platform, the firmware has to invent its own way of resetting the system. But the whole point of having this firmware layer and having this abstraction is that you can reason about it at two levels. So we all reason about it at the EBBR level when we say we want to reset a system, and then someone who builds a system and doesn't have this SBI stuff to reset the system will have to invent its own way to back that particular boot time service. But the fact that there's some platform may exist that has trouble implementing reset system has no bearing whatsoever on what the specification defines.
But so the idea was currently there is nothing in the platform, let's say Hyper-V list, that allows reset. So if we don't define an interface, it will be always incompatible with EBBR because it doesn't have a reset interface. So I mean, we can add the Risc-V to the spec, but then the current platforms would be incompatible because it doesn't have a reset interface. So that's why we wanted to
But do those platforms have an EFI implementation already?
Yeah, it's basically I booted.
Then those will have to be fixed. I mean, then those each will have to provide some implementation of reset system. But how it really works under the hood, it's really a separate issue. I mean, the fact that in some cases it may be complicated to implement reset system doesn't mean we should make it optional or remove it from the specification to which the OS interfaces. Those are separate things.
Okay,
yeah,
so
you're
saying
there's going to be any way around having platform-specific reset stuff in firmware. It's just a platform-specific thing.
Yeah, of course. So in the implementation, that's the whole point of the specification.
Yeah, that's kind of the point, right? If there was a generic way to do it, we wouldn't hide it behind this layer where you can implement it however you want. Right? Yeah, so.
Okay, so then we can agree that we can start adding the Risc-V section to the EBBR spec and make it compatible. And as in when there is a solution for the reset, then we can say that, okay, that platform is compatible with reset, EBBR spec. But in terms of adding to the spec, it's not an issue. In terms of implementing the actual reset, that the platform would take care of, right? Okay, got it.
Yeah, my worry with what we were doing with SBI reset is really that it was just too mushy of a definition. And you end up with like, what does reset actually mean problems? What can I rely on it to do? But if it's another spec and the definition is good enough for those use cases, then that seems fine.
Yeah, so what does other platforms do in terms of, let's say in ARM64, what does they do for, let's say, authenticating system? Or because I know ARM64 has a PCI, so do they just rely on the PCI, or do they define all the platforms also provide a hook for their platform specific things? Was I not clear? So my question was, what does ARM64 have? They have PCI for reset, but in addition to that, does all platform have a platform specific system reset way?
As far as I know, like a lot of platforms actually have implemented the reset thing in ATF, and they provide it through the PSCI reset. And all the hypervisors also implement the reset call, PSCI reset call. Yeah.
So then why we can?
Yeah, so it makes life easier for the UEFI compatible firmware, because now we can just run the UEFI EDK2 or UEFI compliant firmware, which runs natively inside same unmodified firmware can run inside the guest or VM as well. Because finally the EFI reset implementation in those firmwares will call the PSCI call if there is no other way to do it. So.
Then why we can't adopt the same approach and just go through SBI? Is it, like as Palmer said, is it too mushy, like the spec, or?
Yeah, man, I don't think there's any reason we can't do it. The question is really like, what should SBI actually contain in terms of like how broad of a scope should it be? And then can we write a definition of this that I as a user can rely upon to do something interesting? Last time we had a definition for reset, I didn't think it was well enough defined that I would want to write that down and rely on people sticking to that definition.
So you mean where does the scope end, right? Like, should we allow all the platform specific things?
Yeah, I mean, I think to me there's really two different questions. One of them is, so we have SBI, right? And SBI is kind of a Risc-V specific thing. I'll turn my video on because I'm going to be talking. So SBI is sort of a Risc-V specific thing. And things like reset are not as Risc-V specific as things like, I don't know, a TLB shoot down, right? So the question is, like, should we have these platform level things in SBI, or should we just say like, these are part of the platform side specifications like EFI or EBBR or whatever?
Yeah, but that anyways have to go through SBI because there is no other interface to talk to the
then the thing we put in SBI is the mechanism for getting to EFI, which is a Risc-V specific thing, because that that's registers and instructions and that sort of thing. But we don't necessarily define what all of these EFI calls do in the SBI spec. That's defined in EFI land, kind of partitioning the thing up.
So you're saying we go ahead and add it in terms of SBI spec, not adding into SBI spec, and add into the EFI spec for reset?
Well,
like just an
my understanding is that there already is a reset call in EFI.
No, so the EFI call is reset system, right? So let's say Linux calls EFI reset, that's it. But then somebody has to implement something like EDK2 or U-boot. Now, currently,
but that is part of the platform-specific firmware chunk.
Yes, yes, but that's what the question is. If we go ahead and do platform-specific things, then we have to go and do bunch of them for every platforms.
Yeah, but the firmware is going to be platform-specific. I don't think there's really a way around that.
I want to ask a question. Yeah, and I follow the BBL first, and then OpenSPI born out, and OpenSPI. And now we use the U-boot plus to the OpenSPI. Do you suggest me change it to the UEFI with the U-boot or into the EBBR? Is the EBBR is suitable for the embedded system?
So EBBR is just a specification, so you don't have to do anything extra for EBBR. It's just a standard of way to getting the distros, booting distros. So as long as, let's say you are booting BusyBox, you don't need to go to Grub and then do EFI boot or anything. You can happily boot BusyBox with or any small root FS with boot I command in U-boot. But if you want distros, the idea here is to let's say Fedora or RHEL already supports EBBR, and then if they want EFE, so they will provide a package which would be directly when you install on your SD card partition or some partition, you'll be booting OS, like, so without any hassle. So we don't have, currently they have to implement it. The only reason Risc-V is not part of the Fedora mainline builds because it is different from, let's say, all other architectures. So we want to narrow that divide so that it follows the exact same EFE flow for Risc-V as well.
Oh, okay, and I have a look at the Linux tree, and now there is only some SPI function ID definition there, and some extension SPI. Is part of the UEFI, or UEFI should make some code into the Linux tree now?
I think UEFI patches are in the mailing list, so Palmer just put them on next, so it should be in 5.10 merge window. Right?
So
yeah,
the whole
I got a mail about screwing it up, but I will go fix that. So aside from that, it should be 5.10.
Okay. So definitely the whole Risc-V will change it to the UEFI, and the OpenSPI may be deprecated.
No. Sorry. That's what, like, UEFI is a option to boot. It's not the option to boot. So it's for the distros. So if the distros, like, if you can always go and boot using UEFI, but you don't have to unless you're booting a distro. So that's the thing. So it is another option that's provided, which is easier for distro to support Risc-V.
Okay.
That's what I wanted to make it
another question is about the OpenSPI in the GitHub project will be maintained continuously in future.
Yes.
Okay.
It will be maintained at least as long as we are there. So if there is an apocalypse or
thank you.
something
So
happens,
I come, we use it, and we use
it will be maintained.
OpenSPI. Yeah.
It will be maintained, and
maybe
there will be new features will be added. So
yeah,
don't have to worry.
Maybe we would change it to UEFI, but as we want. Yeah.
It depends on what your users want. Yeah.
Okay. Okay.
Okay.
Thank you.
I think I'm also out of time, so you're scheduled for the next talk. So I'll just switch the slides. Thank you everybody for attending and all the comments. It is really helpful. I'll switch the slides. Oh, sorry. Selected the wrong one. Okay. I think I'll just make you presenter and
let me control it. Yeah.
You should be presenter now. Okay.
Yeah. Okay. You can see I move the mouse. Yeah.
Okay. I'll shut up.
Let's start. Yeah. And hi everyone. My name is Guo Ren, and you can call me Gary. Yeah. And I'm from Alibaba T-Head. Yeah. Yesterday I have talked about the K-prompt optimized. Hey, today I have talked a lot yesterday, so I just put the most important thing at first, and I'm working with the Risc-V KU probe implementation, and a lot, and it could work around, and KU probe could be used almost done, but I made some puzzle, and I needed to put it here to let us give me the decision or how we deal with it next. That's the base before I send the next version of patch. Yeah. Okay. Let's begin with the key probe on F-trace. Yeah. F-trace mechanism is made by the Alan, maybe 2 years old, 1 year ago, and he has a YouTube video, but in Chinese. Yeah. But you can get it. Yeah. And here is this is the current our F-trace implementation. Yeah. And it used the core M count. That's from the GCC with the /PG. Yeah, and it will insert call site in your prologue of the function. Yeah, that and it's not very good enough, I think, because another better way is mentioned by Masami. Yeah, and he told us we could use the patchable function entry in F-trace, and then we will let the let the F-trace point call site at the beginning of the function. That means this will put a lot of nope before the prologue of the function. That means it will affect function generation. It's let's have a look at it. Here is the current implementation from Alan, and you can see when the GCC compiler with this option, it will generate this code, and it's used two instructions to jump. Yeah, AUIPC and JARI. It's the very common used in the Risc-V code. Yeah, and when the Linux boot up, when you compile Linux, and Linux will call a script record PL, and they will change this code to the nope. Yeah. No, sorry. They will record this call site. It will record this call site address in the symbol in the symbol, and then when the Linux boot up, and it will change them to the nope. Yeah, and when you enable this function, such as this function, you just enable put it back, and then that is the F-trace ditto mechanism. Yeah, and then trampling to the F-trace caller. Yeah, but it's not the only two instructions. This implementation related to the frame point. That means this implementation, look here, AUIPC will destroy the return address, and then you should push the return address in the same place. And so this instruction, so the current F-trace data mechanism depends on another implying mechanism, frame point mechanism. So it's current implementation. And if we use the fpatch function entry, now here is the solution one. Yeah, if we use the ftrace function entry, we could put a lot of before the prologue function, and we will got a space to put our call site, and we can use this place to data anywhere, and we don't worry about it will replace some replace some instructions. So no need to simulate it. If so, so kprob utilize this. If a kprob point is at the beginning of the function, it will utilize the ftrace data mechanism, ftrace whole mechanism, and the kprob just a callback hook in the ftrace. Yeah, that is the kprob trace feature is. And let's focus on the ftrace data mechanism. Yeah, solution one. How we data in this way? First, we should save our return address first, because we will destroy it, and then we will jump to another place. And when we back, we shall pop up return address, and then continue the our function. Yeah, that is solution one. And solution two, yeah, this solution is have a problem. So many code there, and you know the ARM style or x86 or PowerPC are much better than it. It's much small, little instructions affected. But here is so much instruction there. Here, I don't think it's a good solution. So I give out solution two. The solution two is it's just 3 instructions. Yeah. First we see it's from it's similar to the ARM64. First, we should use a general register to collaborate, and this register should be reserved and cannot be used just for the trampoline, this kind of things. Yeah, so we can use this register to save the return address, and then we use the AUI PC and jump to the ftrace caller. And in the ftrace caller, we could use this register to get the return address. Yeah, that is. And so it's much more clear. And this is solution 2. But the solution 2 cannot be implemented in current Risc-V ERF ABI. So here is my puzzle. So how can I, how should I implement this mechanism? Yeah, solution 1 or solution 2. And Risc-V maintainer should give me some advice. If we choose solution 2, we should need to modify the ELF ABI first of the Risc-V. Anybody suggestion here?
I haven't been paying enough attention. I was looking at the chat.
Okay. Thank you, Palmer.
Can we modify the ABI now? You're talking the PS ABI, right?
I mean, we can extend the ABI. And then also, like, this is in kernel ABI, which would not necessarily need to be the same as, you know, like user shared library ABI, right? You can like kernel ABI is not stable. So, but I mean, it's probably not the way to go, just because it would be a lot of complexity for something where I'm not really convinced that the performance is tremendously important.
This data mechanism also affect the kprob optimization, jump optimization. If we couldn't deal with it correctly, we also could not implement the kprob jump optimization correctly. So they are related. We will find the key question is we should find a way how to detail our instruction flow. Yeah, and the key question is we don't have a very large range branch instruction. x86 have 2 gigabytes, 5-byte instructions, and ARM64 have 26-bit wide instruction BL, and it could jump forward 128 megabytes and back, and Risc-V only 16 bits wide. It's very small, so we need to use AUIPC. If we use AUIPC, we will use we will cost a register, and we cost a register. We will get some push and pop, or we could reserve a register. It's not I really want a large range of branch instruction in the Risc-V. Yeah. But how?
Yeah,
how,
I mean, it'd be great to have, but it doesn't fit.
we need a K-probe. Yeah, we need a good implementation of F-trace. We need a good implementation of the K-probe optimization, because when we K-probe a lot of a guy I have mentioned in yesterday's presentation, that's the complaint of the K-probe cost, because two exception is too expensive. Exception is too expensive. We need a branch, and the branch, well, the data mechanism is very good performance, and that will make the instrument measurement, the time measurement, some performance measurement more correct.
So does this mean that X9 is now reserved? So you kind of like have one less register?
Yeah, I recommend the solution. Yeah, but it's to modify.
Can't you K-probe at like arbitrary instructions?
K-probe the arbitrary.
Right. Sorry, this is F-trace stuff. So F-trace only exists for defined call points, right?
Oh, okay. Masami
Yeah.
here. Yeah. Okay.
Yeah, of course that the F-trace is a function tracer, so that you only can put on the let's say entry of the function.
Trying to hold more than one conversation at once. But if S-trace is only for defined call points, then yeah, we can just, because the call points already trash the temporary registers. So just use the temporary register for your scratch stuff, and then it's fine.
Use the scratch.
Yeah, that's something good, but in that case, you cannot trace the temporary registers. Yeah, it's will not matter. Maybe, yeah, because those registers will not be used until inside in that context.
Because the function can't rely on anything about those temporary registers, so there can't be any stuff in there, and the caller has to assume that they get trashed. So I don't think there'll be anything in those that's noticeable, if that kind of makes sense.
Yeah, the problem is actually that the K-probes is let's say normal K-probe. It based on the break instruction, so that it can save all registers at that point. Moment.
I agree. That doesn't work for K-probes because you
go
start poking arbitrary.
The problem is the user cannot choose to use the optimized probe or F-trace or normal K-probes. In that case, that the user has to prepare their handler, so that the function, they cannot change their user functions, user handlers of the K-probes event. Yeah, it means that if we change the behavior based on the place, the result will not much. I say will be different, but we can user cannot control it.
Yeah, I guess maybe I'm kind of misunderstanding the problem then.
Yeah, Palmer, and you are the maintainer of Risc-V. You must make sense of this mechanism and make the decision, because that's will affect my next version how to work the patch. Yeah, the patch.
Yeah, I will go look closer.
Yeah.
But I think at least to start, just picking the version that does not require compiler changes is the way to go.
Okay, let's vote. Let's have a vote. Let's see the audience choose A or B.
Make a little suggestion? Can I make a little suggestion?
Okay.
It might not be relevant, but it keeps occurring to me this big block of knops could perhaps be replaced by a single knop, and the one substitute instruction you replace is a short backwards jump to whatever little trampoline you want, doing whatever you like, that has no impact on the function, not even as a sequence of knops when it's not tracing.
Yeah, I was gonna mention something similar. Is like we have some fixed registers, so you can jump off any register, right? So we could easily store the relevant trampoline over there.
Well, you could also jump backwards into a few instructions just before the start of the function, which will have like negligible performance effect. You just take a little space.
Yeah. We'd need some way to distribute those. But yeah, that would be a viable solution as well, right? Like we have similar problems with some of our, kind of sparse memory embedded systems where you want to program the whole thing. We're figuring out how to distribute these tables of trampolines or constant pools or whatever.
That doesn't mean
I'm not convinced we can do that without some compiler work, but it certainly would be a way to do it.
Jamie, conclusion your advice is that you need to prepare a data buffer around this area and use the small branch there, and then.
Yeah, that's the idea. I mean, it could be little. It doesn't really matter they are, as long as they're within a short branch range.
Yeah, I mean, basically just put your no-op buffer out of line rather than in line, right?
Yeah.
And if you put it before the function, it never, maybe it eats some cache or whatever, but it never really gets used. And some of our other code models may end up with mechanisms to distribute these reachable regions, I guess, throughout the binary. So that may be a thing that would get sorted out with some compiler infrastructure that'd be useful for other things as well.
Yeah, that sounds like even a linker relaxation type thing.
Yeah, I mean, the general theory there is that you would the compiler would go spit out whatever trampoline region you want. We've looked at them mostly for like large address support, right? So you're basically you need a constant pool that is within a shorter range of your PC, right? You do the Howie PC in the load, so you get a 2 gig region. So the compiler would just spit the constant pool out for every function and include some relocations that would allow the linker to then go merge those constant pools. It smells quite similar to this in terms of first order infrastructure stuff. The tricky part is how do you actually distribute those throughout the binary without losing your mind in the linker? But I think if we can sort that out, we can have slightly different semantics for how to merge them.
I would put as a starting point, you put it at the start of the function or in some alternate section repeatedly, but then you use linker relaxation to eliminate them where they're duplicates, where it can.
Yeah. I mean, that's basically the hard part, is how to actually relax that stuff away, because for the other code models, we're looking at embedded stuff where you really need to optimize that really well, because because otherwise you're going to have horrible code size. But for this, you don't need to worry about it so much, right? So maybe we can get away with just not not worrying about relaxation right now and just kind of get on with our lives, fix it later. Yeah.
That was it. That was my idea. I suppose option C.
Everybody could vote at the right of the screen, and we only get two tickets, and I want to see which one you choose, and solution one, do you hi Palmer, do you accept the solution one? Affect,
I mean, I gotta look at more detail than this, but I don't think there's anything like fundamentally wrong with requiring a few more instructions to do the f-trace.
Because you have
I have a question about the solution one. Do we need the last two instructions to fix up that? It seems that the fixing up the stack pointer, right?
You mean the instruction is could be deprecated, but how we
fixing up the stack pointer in f-trace trampoline, so that not directly call the f-trace scorer, but f-trace making an f-trace trampoline code. And at the last point of the f-trace trampoline code, you can put these are stack pointer fixing up.
But the first question is the Risc-V direct jump instruction is limited. It's have very small range. So when we back, we still use
back by your
still need to return
from link register or something like that? A function return.
You mean in this function we could prepare the I and SP, but how we return here, because it's far away, and when we return here, and we still need to register. That is the puzzle. So I still need to keep to this instruction. More in the mail list, and I will show you.
Yeah, but I think that you can break some link register or something like that.
No, we cannot break any register here because it's in the function call, and the callee and the caller and the callee and have parent caller, grandfather caller, and caller, and so you don't know what's register. You should keep all registers there. And when getting, you need to save all of them.
Okay. Yeah, I got it.
That's so Augustine implementation for me. If I send the next page with this, would you approve?
I mean, I'd have to look at the whole. I don't think picking version A is an issue for getting this merged. There may be other issues. I don't remember the patch set particularly.
But I only get 6 tickets. I need more people vote, and it don't make sense. You ask me directly, and I will let you know that. And please vote your give your. I need your ticket, and then I need your choice. Alan call here, or seems he don't hear.
Yeah, one other small thing. The other challenge I see with both these solutions is that you're going to have an alternative entry point alongside f-trace as well, right? Your f-trace will still have its own set of instructions, and you're going to be inserting a lot more knobs, increasing the text size as well. So one other thing you could consider is for PowerPC, what we've also done is we came up with a new ftrace ABI for the kernel. It's the M-profile kernel. That's the option that we use with GCC. So if you think the existing ftrace, how it works for Risc-V is not ideal, you could consider adding a separate mechanism which could potentially solve both of your issues. With the right sort of instructions at the beginning of the function, which on top of which you'll be able to write for K-probes on ftrace.
Yeah. Sorry, I not make sense. Yeah. Yeah. And yeah, but I know you work with the IBM, and we can talk in the mail list, and I think the PowerPC have the same problem because his implementation also is not good, and because he is limited with the in this 64, and maybe he need a large range. Yeah. Okay, I will illustrate the result of the vote. Yeah, we only get 7 tickets, and 5 choice A and 2 choice B, plus me. I chose B, but seems I needed to implementation A. Yeah. Okay. And okay, it's that's next. Let's get next. So another work is live patch. Yeah. In fact, live patch just with the dynamic ftrace, if we implemented with the dynamic ftrace with Rex, and it could change the return address in the ptrex, and then it could modify the return address, then it work. But if we need the full feature of the live patch, we need to check his in the document it said consistent model. Yeah. And the full consistent model need 2 features: reliable stack trace, and
so I think we're over time here, unless I'm happy to keep talking, but this is officially a break. So
okay,
people want to wander
it's not
off.
important things. Yeah, and it's not important. Okay, thank you everybody, and break. Bye bye. Yeah.
All right, bye guys.
Have a break. Yeah.
Okay, so we have a couple minutes left. Anoop, I assume you're set up to talk.
So I had already uploaded the slides, right? So I don't need to share anything, right? Okay.
Yeah, I mean, if your slides or whatever is on Plumbers, then they will appear here.
Okay. Okay.
You'll get some little buttons down at the bottom to do the presentation stuff, so you can control your own slides.
Okay.
Yeah, swap them over here for you. Okay. Nope. Okay, so you should own the slideshow now.
Okay.
I guess green time is next. So green time, I assume you're all good with whatever you uploaded as well. Otherwise, I guess we can chat or something.
Yeah, I can change the slides.
Yeah, cool. So I think we'll just try to start on time, which is in like a couple minutes.
Okay. My webcam is not working, so you might not be able to see me.
That's fine. Just don't worry about it.
Yeah. Anyways, you know each other. Yes.
Yeah. I mean, just talking. It's more useful for the people who are like not giving the talk, because then you actually appear. So if someone can tell that you're trying to say something.
Okay. Yeah, that's true.
Yeah.
Yeah, but I'll keep looking at the chat window. No problem.
Yeah. That's the most questions come in from there anyway. It's a little easier than trying to interrupt the talk.
Okay.
What do you mean by the download is not enabled in the upload list?
If you go to the upload presentation, there is there are three options. One is to enable download, so that download option appears in the slides.
Enable, do not allow presentation to be downloaded?
Yeah.
I see a button that says do not allow presentation to be downloaded.
Yeah, so then you unmark it so that you allow the presentation
It looks like they're all unmarked, except whatever is called default.
Huh.
So
then mark it probably. Then mark it and then say probably. Mark it and see.
Okay. Either way, all these things are on the
no, there is no. There is a download button, but
why don't you just do it if you know how to do it, man?
No. Actually, it's correct. The option is not visible because of the slides. The background is black, so if you hover around the bottom left, there is a download the original presentation, and I am able to download. It's just that it's difficult to see that because of the background of the slide.
I don't think I can download that where there was in previous presentations.
This one I can download. This one I see there's a, if you hover around, there's a button. Yeah, right there.
Oh yeah, off the slides, right? Got it.
Yeah, the template is really bad for this one.
Okay, yeah, I can see it now.
Yeah, we should have chosen a different template from. I think all Western digital slides have this template, and it's really tricky to add it. It's all the slides also will be available in the Risc-V Mc conference website, so you can go there and download also. It's uploaded there.
Yeah, I think it's time to get going here, though.
Yeah, we'll get started. Hey everyone, I'm Anoop, and sorry about you cannot see me. My webcam is not working with the UI. Anyways, we'll get started. So this session is all about the current state of the Risc-V hypervisor support and the ongoing work that we are doing right now for the hypervisors. Yeah, and primarily we'll talk about KVM. So we start with a very short, brief status on the Risc-V Edge extension spec, and then move on to the KVM Risc-V status, and then spend more time on the Risc-V nested virtualization stuff, where we have some ideas, and we also want some feedback on that. Let's start. So the Edge extension spec, and for the people who are new to the Risc-V world, the hypervisor specific ISA in the Risc-V world is called Risc-V Edge extension. The key contributors for this Risc-V spec, Edge extension spec are Andrew Waterman, John Hauser, Paulo Business. So these are the people who actually started the whole Edge extension spec and got to a good shape, after which like a lot of people started giving feedbacks, you know. So there has been a lot of draft releases since like November 2017, and like this November all the draft releases will like would have spent like 3 years now. So it has spent a lot of time in review actually. And the latest draft release is 0.6.1, like which was released on 5th May. It was just a minor change related to some nested virtualization stuff we wanted, and most likely, hopefully, this will be the last draft release. Not sure still, but then, and Western Digital has been doing co-development with the Risc-V Edge extension spec since 0.4 drive, which was like a year back. So we started off with porting the QEMU first. Alistair did all the work, and then we ported 2 hypervisors, Xvisor and KVM, just to prove the functional correctness of the spec. And then from there, like we are continuously updating the implementations in all this. Even OpenSBI has some level of Edge extension support to redirect the traps and do misaligned roster emulation for the guest or VM if it is not supported. So moving on to the KVM Risc-V status, how far we have got on this front. So again, for people who are new, actually, so with Edge extension, when we are running KVM, these are the privilege levels and the software layers you will see. The firmware, M-mode firmware is the most privileged. It's OpenSBI, which provides SBI services to the HS mode or the host Linux. And even the KVM kernel module runs at the HS level. Then we have guest Linux running at VS level, and then we have guest user space at VU level. And the QEMU or KVM user space tool of the KVM runs in U mode, non-virtualized mode. And as such, the VS and HS modes are nothing but the S mode with different capabilities. So technically, unmodified Linux Risc-V can run as both in HS as well as VS mode. Only the KVM part of the host Linux uses the hypervisor functionality of the hardware. So this is the list of things we have done so far. Compared to last RPC, the red items are the new things that we have achieved over the year, and then there are other patch sets. So of course, we have moved the KVM Risc-V patches to the latest draft spec, that is 0.6.1. And then now we support both RV32 and RV64 hosts, which means like you can run KVM on QEMU 32-bit and QEMU 64-bit. And by the way, yeah, KVM also works fine on Spike as well. So we recently added Spike support for Edge extension, and tested both Xvisor and KVM over there. And then Atish added the SBI 0.2 interface for the guest. Okay, this is a separate series, so it's not part of the main KVM Risc-V series. And then we are forwarding unhandled SBI calls to the user space. So even user space, KVM user space has a chance to handle vendor-specific SBI calls or experimental SBI calls in user space. And recently, Huawei, I think, had sent out patches to get virt vhost working with KVM Risc-V along with using IO event FT. So again, those were like small changes, and those are RFC patches. So about the patches, actually, we had submitted the first version of the KVM Risc-V like back in July 29, 2019. It's like almost more than a year back. So, and the patches were like reviewed and hacked by V6 like in a couple of months. And since then, like we are maintaining the patches with changing draft spec. and also ensuring that corresponding things keep working with every kernel releases. So what happens is that with every kernel releases, even the our current KVM layer also breaks because of the changing interface in the generic kernel KVM module. So we keep maintaining that. And apart from that, a few other patches were submitted. Like I mentioned, the vhost support, which is again in RFC state, and SBI 0.2 support to server RFC. These patches, which are not the original KVM RISC-V patches, are still blocked because we need first the KVM RISC-V patches to be merged. And these bottom three links are like the important links if you want to follow the KVM RISC-V efforts. The last link, particularly the wiki, we have some pages which will help you to play around with KVM RISC-V on QEMU and Spike. Yeah, so what's next on our list? Actually, the to-do list is pretty big. If I were to make slides, it will go on. So I just created the to-do list for the immediate things that we are working on. But there's a lot of things to be worked on for the KVM to make a server class virtualization solution. So right now we are working on two things, at least I'm focusing on two things immediately, is that stage 2 dirty page logging. So there is a generic implementation in KVM, generic kernel KVM, which has a dirty page logging support, which we want to leverage with KVM RISC-V. And then we have nested virtualization, which is a bigger piece and more complicated thing. So that I started looking into. Then the other things like next we can look at is trace points. The KVM unit test support is very important to get CI up and running for KVM RISC-V. Then you need to virtualize the vector extension, because that's another RISC-V extension which is close to free state and will require some save restore. And then we have guest VM or migration support. This is required for server class virtualization again. And the other things are like fancy things like running 32-bit guest on 64-bit and running big Indian guest on little Indian. And for these things, like even simulator is not there. So we'll wait out on these ones. So moving to the discussion part of this session, actually, we have some ideas about how to go about doing nested virtualization in RISC-V. So I'll explain those ideas, and maybe you can suggest some feedback, or if there is some issue with what we are discussing, you can please interrupt me. So this is the high-level view, high-level view of the KVM RISC-V. But in this case, we are showing hypervisor running inside another hypervisor. That's why it's a nested virtualization. So the host hypervisor, or the native the hypervisor which runs natively directly on the hardware under M mode, is called the host hypervisor. It runs in HS mode. And the hypervisor which runs inside the host hypervisor is called the guest hypervisor. And then the OS which finally runs inside the guest hyper VM is called guest. We are calling it guest Linux over here. And then it will have a user space called guest user space, and then we'll have guest hypervisor user space as well. So with these additional layers of the software, we are not actually increasing the privilege modes. Okay, if the terms that you see in this high-level view, the virtual access mode, virtual VS mode, virtual VU, these are all pseudo and dummy privilege modes, which are actually functionally emulated by the host hypervisor using the existing VS and VU modes. And this is like you can have any level. Theoretically, you can have any levels of nesting, but the performance will keep degrading with every level. Actually. It's like that Inception movie where the dream inside dream, and the time scale changes with every dream you get nested into.
So, Anup, the prior page listed a list of all the items that you have. Is that based on priority, or is it just, nice to dos?
Yeah, nice to dos. Yeah. We have not prioritized this as of now. Yeah, but if there is some important stuff to be done before, then please let us know. We'll do that thing. Yeah. So right now we chose to do nested virtualization before guest migration, because nested virtualization will add more context to the guest vCPUs, which needs to be migrated. So if we would have done guest migration before nested, then we'll need to do more versioning of the vCPU states.
Hi, Anu. the nested virtualization needed to modify the hyperversion as specification in the privilege specification. We need more hardware or just the OS software.
Yeah, it's so all the virtual prefixes that you will see from the slides now on are virtual things are implemented by software host hypervisor. They are not required in the hardware. Yeah.
Yeah. So and it's not the only 3 stage, maybe 4 stage or more, and it could nested one by one.
Correct. So just think about it. When guest Linux is running on top of guest hypervisor, which is in turn running on top of host hyper, we are actually having 3-stage translation.
Okay. Yeah. But yeah. So the stage translation, because in hardware we have 2 stages translation, and that means you need to more stage translation, nested stages translation in hardware design.
Yeah, so I have a slide for that. Actually, how we condense the 2 stages into one stage as a shadow stage in software, and with the existing hardware or the existing spec, which only supports 2 stages, we can actually emulate 3 stages actually. Okay. So going into more details, like so with HS mode, we have like additional CSRs which a hypervisor can access, and we have additional instructions like hfence, HLV, HSV instruction, which we call it hypervisor instructions. Okay. So when we are doing nested virtualization, these CSRs and hypervisor instructions will be accessed from the VS mode as well, which means the guest hyper will try to access these CSRs, and assuming that it's running in HS mode. So these instructions and CSRs will trap as a virtual instruction trap, and based on which mode we came from, we'll actually either emulate this CSR instruction or redirect them to the guest hypervisor. For instance, if the trap came from the virtual HS mode, which means if we came from the guest hypervisor tried to access the hypervisor CSR, then the host hypervisor will emulate the hypervisor CSR and the instruction. But if the trap came from virtual VS or virtual VU mode, then we just redirect the hypervisor CSR instruction trap back to the guest hypervisor. Same, if the trap came from virtual U mode, then we convert the virtual instruction trap into an illegal instruction trap and redirect it back to the guest hypervisor. So more details like how will we handle like WFI traps and ECOR traps. So WFI traps are interesting one because that saves a lot of power, because when guest or VM is idle, it will do WFI, it will trap to the whole hypervisor, and hypervisor will block the vCPU. So when we get a WFI trap in host hypervisor, again depending on where we came from, will behave differently. So if the trap was from virtual HS mode, which means the WFI was done by the guest hypervisor, then we just emulate the WFI, which means we block the vCPU and do the normal behavior which is there right now. And then if we came from virtual VS mode, then we have 2 cases. Either the virtual edge status of the guest hypervisor has the TW bit set or off. If it has set, then we redirect the WFI trap back to the guest hypervisor. Otherwise, we skip the WFI instruction, treating it as NOP. And if the trap came from virtual VU mode, we just again blindly redirect the WFI trap to the guest hypervisor. Similarly, just like the hypervisor CSR instruction, if the trap came from the virtual U mode, we just redirect back to the guest hypervisor as illegal instruction trap. So handling ECOR traps is much more simpler compared to WFI traps and the CSR and the instruction traps, because there are only 2 cases when an ECOR trap happens in the host hypervisor. Either it was by virtual HS mode or it was by virtual VS mode. If it was by virtual HS mode, which means that if the guest hypervisor did the SBI call, we emulate it assuming it's an SBI call from the guest hypervisor. Otherwise, if it was virtual VS mode, we just route it back to the guest hypervisor. coming to the most challenging part of this nested virtualization is the emulating two-stage MMU for the guest hypervisor. In other words, we want to emulate the G-stage translation for the guest hypervisor. So, like Gio mentioned, actually, when we are doing, we have 2 levels of hypervisor. We are actually having, and we are running Linux at the 3rd level. It means that we are actually having 3-stage translation, but the hardware or the spec only defines 2-stage translations. How do we do that actually? So to achieve that thing, host hypervisor will create two G-stage page tables. One is the normal G-stage page table, which will do the translation for the virtual HSN U mode, which means there will be a regular G-stage page table, which will do translation for the guest hypervisor and the guest hypervisor user space. And there will be a shadow G-stage page table, which will do the translation for the virtual VS and VU mode. Now, this is a shadow page table, okay? It's not exactly like the normal G-stage table. It will have limited number of entries, and we'll have to do a software walk of the guest hypervisor G-stage and also look at the regions on the for that guest or VM in host hyper, and the combined effect of the 2 stages we'll have to create using just shadow page table. And if there is a missing entry in the guest hypervisor G stage, like a missing PT, we'll just forward it as guest page faults. And hfence instruction traps from the guest hypervisor will work on will update the guest shadow page table. Another interesting part is that we'll have only one normal G-stage page table for each VM, a guest or VM in KVM or any other hypervisor. And shadow G-stage page table would be like per vCPU of the guest or VM. So if a guest is having 4 vCPUs, then it will have one normal G-stage page table and 4 shadow G-stage page tables. So yeah, and again, how to deal with VM IDs. So as of now, the most brain dead or naive approach will be to share the VM ID, but this is very expensive because if we are sharing the same VM ID for normal and shadow G-stage page table, we'll have to flush every time we move, do a nested world switch. The other approach is to allocate 2 VM IDs per guest or VM, and there are other ways to solve it. Yeah, so this on the right side is like pictorial representation of what the shadow G-stage will translate and what normal G-stage will translate.
Anoop, I have a question. Slide. Yeah, it's confused me. Yeah, that means all stage, whatever kind of the stage of the virtual machine, maybe very child, maybe child, maybe 3-stage or 4-stage virtual machine, all will to the 2-stage translation to the root hypervisor with the G stage.
Yeah.
Yeah. Oh, that means whatever you are, you all will get use the G stage, and then get into the root hypervisor, and that root hypervisor will translate the any level of the virtual machine. Is that?
Yes, this like it works theoretically, but you know, managing the shadow G-stage page table becomes an overhead. We cannot have too many entries because we end up removing entries based on hfence instructions, and so and also we end up doing some on some occasion we end up doing TLB and TLB flushes for that VM. So it becomes slower compared to so as we moved on to multiple levels of hypervisors, the performance degrades actually. So
and here there is difference is normal G-stage and shadow G-stage, and the normal G-stage is for the hypervisor and virtual hypervisor, yeah, and the shadow G-stage stage for the virtual guest, yeah, guest.
Yeah.
So what's the difference between the normal G-stage and the G-stage here? Almost share the same VM ID assigned for the.
So the normal G-stage page table is the same thing that we have implemented currently. So right now we are not running any hypervisor inside Gaster VM. We are just booting plain Linux, right? So whatever page table we are, the G-stage page table that we are creating, the stage 2 page table code that you see right now in KVM Risc-V is the normal G-stage page table. Okay. And then on top of this, we'll also have another G-stage page table. So right now we are populating the normal G-stage page table based on the guest memory regions that are defined in the generic KVM APIs for that VM. But when we want to populate a shadow G-stage page table, we have to look at two things. First, for that guest physical address, we have to walk through the guest hypervisor G-stage page table, which means the guest hypervisor would also have programmed its own virtual HG-ATP CSR, which is pointing to some its own stage 2. Okay. So whenever you want to program a shadow G-stage page table, we look at the PT in the guest hypervisor G-stage, and based on the mapping, we further modify the mapping based on the KVM guest regions, and then write a modified entry into shadow G-stage page table.
Okay, I got it. So, but I think there is every hypervisor virtual hypervisor has its own VM ID identify, and this VM ID is the cache, but there are a unique VM ID for every virtual hypervisor, isn't it? And when the VM ID changed, all SID should be flushed. And when you extend the context switch in the hypervisor.
Yeah, so I think it's a good question. So, so you're right. So if you look at this diagram, so host hypervisor, that's a hardware supports VMID. Okay, so the host hypervisor will use all the VMIDs, and it will emulate a virtual HG-ATP CSR for the guest hypervisor. Okay. But we don't have infinite number of VMIDs or which we can partition and share from the. So what we do is we emulate a virtual HG-ATP CSR which has no VMIDs for the guest, which means that the guest hypervisor will have no VMIDs. So it will end up doing flushing on every vCPU switch.
So you mean guest hypervisor don't have the own has the same VMID with the guest hypervisor. I mean,
yeah. So and the guest hypervisor is also most of the time Linux, and then the guest, and then is further running another guest Linux. So when we switch to virtual VS mode with the same VMID, we might actually accidentally hit TLB entries of guest hypervisor. So to avoid that, we have to flush when we are switching from virtual VS to virtual HS to virtual VS and vice versa actually. So I think I am running out of time. I'll just quickly do. I had one more slide. Yeah, so the other critical part about the nested virtualization is the additional virt switch that we introduce, or which we call as a nested virt switch, which is nothing but when we are moving from guest hypervisor to guest Linux. In other words, when we are moving from virtual access mode to virtual VS or VU mode, or vice versa, it's a nested virt switch actually. So the switching from virtual access mode to virtual VS to VU mode is actually voluntary. Because the guest hypervisor decides to run the guest Linux, and this happens when it runs an accelerate instruction with virtual when virtual status.spv is 1, and that's a voluntary exit, and it's easy to trap and emulate. And then we have guest Linux to guest hypervisor switch, which is like an involuntary switch, which generally happens when we are injecting an interrupt to the guest hypervisor, or we are injecting guest page faults to the guest hypervisor, or we are redirecting some virtual instruction trap to the guest hypervisor.
And the all stage of the hypervisor context switch are happened root hypervisor. That means if the virtual hypervisor have another virtual hypervisor, and this virtual hypervisor have another virtual hypervisor, but context switching in the root hypervisor is the same level, isn't that?
Correct.
This?
Correct. Yeah, that's absolutely correct. All the traps will be routed. The traps will go through the host hypervisor, routed to guest hypervisor. If you have one more hypervisor, it will route it through this guest hypervisor to another guest level, guest 2 hypervisor. Yeah, so it will be like a tree structure.
Okay, that's so interesting. This picture is simple. Maybe you can give out a more complex picture. That's hypervisor, a lot of oh my god.
This is a simplified picture again, and like we are just starting on this work, and we'll have more idea as we go along, and maybe I'll improve this visualization actually.
Yeah. I first heard about the nested hypervisor is from V8.2 maybe, yeah, but I don't make sense. And today I'm a little bit.
Good that you actually mentioned about ARM. So what happened with ARM V8 was like V8.0 brought hypervisor support. All that is fine. But when they eventually started thinking about the nested virtualization, the trapping mechanism required to do the nested virtualization in software was missing. So far with ARM V8.2, actually they first added the trapping mechanism. Okay. Eventually, what they realized was like the trapping mechanism is fine, it works functionally fine, but it's too slow. So with I think 8.4 or 8.3, they added the second acceleration improvement for the nested virtualization in hardware, where they can save certain trap and emulation for the host hypervisor and do it in hardware actually through memory writes. So that eventually we can even do for Risc-V hypervisor H extension support, but not now immediately. Right now, first thing is to get a software nested virtualization working.
Oh, another problem. Yeah, and I think the Risc-V, the hypervisor specification is similar to the x86. It's similar to the ARM, and I mean one thing. One thing is about the root page table, and in ARM and Risc-V, we all put the root page table in the GVA, but I remember the GPA, but I remember the x86 is HPA, so there is no way let x86 to implement nested virtualization, isn't that?
I think x86 has, but I have not investigated how they are doing. So they have a very different way of virtualizing. So they have. So I cannot comment on that. They certainly have that, but we need to investigate that how it's. But yeah. So what we have right now is like very less CSRs compared to what ARM has, and it's similar or quite close. I would say not exactly similar, because we have different number of pieces. So it's close to ARM virtualization host extension, which they added later to accelerate the KVM. So which was like part of V8.1 actually. So
okay, that's to G stage. Okay.
I think your time is up also. So this is the time for the break.
We got to talk, right?
We have a talk, right?
Oh, sorry. Yeah, I got confused. We have a talk for the vector.
Yeah. Swap the slides over here. Green Time, do you want to be the presenter?
Yeah, white background slides works really well for the download button. Now you can see the download button.
Yeah. I was so confused. It's like, what do I do?
Yeah. Sorry for that.
All right, so I think we're ready to go because this rolled up against the end.
Hi everyone, I'm Green Tan, and this is Vincent. Hi everyone, I'm Vincent. Hi everyone, we're going to talk about the Risc-V vector support in Linux. Okay, and then this is our outline today. That we are going to talk about what is Risc-V vector and its current status. And Vincent will talk about the user space porting, and I will talk about the kernel space porting. And after that, we'll have conclusions and reference pages. Okay, so what is Risc-V vector? From the Risc-V reader book, it says it is a data label parallelism, and it can compute a lot of data concurrently, and it's a more elegant SIMD. And the size of vector register is determined by the implementation. So what the advantage of it? The programmer don't need to rewrite the code again, and it could use fewer instructions than SIMD. However, because the size of vector register is implementation defined, so that every code may have different kinds of vector lengths. And how do we know the vector length? We could read it from a CSR VLAN-B. So take an example. If your VLAN is 512 bits and that's 64 bits, that's 64 bytes per register. So we have all 32 vector register which would cause 2 kilobytes space. So in the current Risc-V vector status is that the spec version 0.9 is released, and in Jivac we sent some patches, and there are some patches is still working in progress, and mostly is for optimized for the memory copy or string compare, string length, such a kind of function that we could implement the vector version for that. And in the Linux kernel, we send a version 6 IFC patch based on 0.9 spec. And there are some features are still working in progress, like kernel mode vector and lazy vector. And we have done some tests in Spike and QEMU with our user space vector test case and the kernel mode XOR. We also run the stress engine to test it. So this is the porting overview. Today we were going to talk the executable, and we will talk about how this executable use the generic version or the vector version by iFunc. And we will talk about the signal handler and how should a kernel set up the SIG context. And we will talk about the vector context information about the header, how to define the header in kernel space or in the user space. And we will talk about context switch and also the ptrace system call. Okay, now I will hand over to Vincent. He will talk about the user space porting. Then after that, I will talk about the kernel space.
Hi, folks. Here I want to share some experience of adding V extension into the gBC toolchain. And as Green Tai mentioned earlier, the V extension is primarily used to speed up the data processing. So our colleague also try to use V extension to optimize the well-known gBC functions such as memory copy, memory set, and string copy. And so my first goal is to integrate this optimize function into the gBC. And in addition, we find some of the existing gBC features were broken due to the influence of the V extension. So the next goal is we will make the existing gBC feature work as usual. Let's go to the first topic: how to use the optimize function. How to integrate the optimize function into the gBC. In this case, I think the most intuitive method to do this is directly replace the current implementation with the optimize function, but it will decrease the function portability. So we introduce the GNU indirect function support, also known as ifunc, to Risc-V gBC. And it can make gBC follow users' rule to select an appropriate function based on the hardware capability in runtime. In other words, if the platform has V extension support, the gBC will follow user rule to select the V extension optimize function instead of the original function. The most of the effort to add GNU support into the ifunc support into the Risc-V toolchain is in the virt. So I'm very grateful to Nielsen Zhu for adding ifunc support to the GCC and the virt. Now, the optimize function has been able to integrate to the gBC toolchain. Then we will go to the next topic. Make the existing gBC feature work as usual. I think for the current gBC, V extension means a bunch of new instruction and a new register. So I think most of the work is to address the EBBR issues such as coding convention. So in gBC, I think the ABI, there are two kinds of ABI. One is between the two binary in user space, and the other one is between the gBC and the kernel. For the user space case, according to the coding convention rule in the 0.9 spec, we check all of the assembly code function, and we find that we need to add some save and restore mechanism for VCSR in seek context function and the get context and the swap context function. And for the ABI between kernel and the gBC, according to the spec, all the vector registers are called safe register. So when exception or interrupt happens, kernel needs to ensure the correctness of vector context across the privilege mode transition. And other than exception and interrupt, signal handler also belongs to this case. This is because the caller of the signal handler is kernel, not a usual function in user space. And in addition, gBC also provides user with some information to handle the received signal, such as seek context structure or signal stack. So a simplified signal processing flow is shown in this slide. Before jump into signal handler, kernel will help process to set up a requirement environment for signal handler, such as signal stack. And in order to avoid the process context is destroyed in the signal handler, kernel will use a SIG context structure defined in kernel SIG context head file to save the context to the signal stack. And after jumping to the signal handler, user may use the gBC SIG context to access the signal stack to get the required process context. So we can see that the SIG context structure used in kernel and in gBC comes from two different files. One is in kernel SIG context head file, and the other one is in gBC SIG context head file. So if we hope the above mechanism can work in vector environment, we need to add the vector register to SIG context structure in Linux and the gBC. And it also means that every time we support a new extension, we need to modify the SIG context structure in Linux and the gBC too. So idea come to my mind. Could we make gBC include a kernel SIG context head file? I think the answer is yes. It is because the gBC generic SIG context head file already did that. But if we directly replace the Risc-V SIG context head file with the kernel SIG context head file, some program may encounter ABI incompatible issue. Why? I think the reason can be found in these slides. The gBC context structure and the Linux SIG context structure are listed in these two figures. We can find they have the same memory layout, but the element names are different. So if we force the gBC context to be aligned with the Linux kernel SIG context structure, a program which has used the gBC SIG context structure will fail to compile. I think libgcc is one of the examples. The libgcc unwinded schemes use gBC SIG context to get the return address from the signal stack. So this change will make the libgcc will break the libgcc unwind scheme and make libgcc cannot be compiled. By the way, LLVM doesn't have this issue because it direct access the signal stack, signal context through the memory offset. So in order to evaluate the impact of this change, I quickly resolve the libgcc issue and follow Jim Wilson's suggestion to build multiple images by open embedded. And fortunately, I didn't encounter any build error. So from this result, I guess that the impact of this change may not be serious at this moment. And I think right now may be a good moment to do this change. So I have sent a RFC page to the gBC mailing list. And if someone have other idea or other feedback or other concerns, please don't hesitate to post them to the discussion thread in the gBC mailing list. And now user can successfully get the vector context from the signal stack. But there has another ABI issue. And this slide shows the UCG scenario. If a user wants to specify a memory region as the signal stack, how does he to know the appropriate signal stack size? in general, user can use 2 macro to quickly get the information. One macro is minimal signal stack size, which specify the minimal stack size for a signal handler. So it would be greater or equal to the size of SIG context structure. And then the other macro is signal stack size. It is a system default specify the stack size that would be used to cover the usual case. So the value of the signal stack size would be 3 to 4 times of minimal signal stack size. Because minimal signal stack size is a constant value, so in general, folks will define the minimal signal stack size as the SIG context struct size, or maybe greater than the signal context struct size. But when introducing the V extension, the above rule cannot followed. It is because the theoretical maximum VLAN is 2 to power of x length minus 1. It will cause the SIG context struct size to be an astronomical number as well. So how to determine the minimal signal stack size and the signal stack size? Here we propose a method to solve this issue. In order to make the original mechanism still can work, we assume the maximum VLAN as 4K bit and used to define the minimal signal stack size and the signal stack size. So users still can use these 2 macro to allocate the required memory region to as the signal stack. In addition, we reference to ARM64 implementation, which create a new accessory entry for kernel to pass the precise minimal signal stack size to user. So it gives user a way to adjust its memory and to avoid wasting memory if the physical VLAN is smaller than 4K bit. It also provides the user that if he can break the 4K bit, the 4K bit assumption if its maximum VLAN is greater than 4K bit. I have finished the above implementation, and it can be found in the following IFC page. And this page will be included in the kernel IFC vector page set. So finally, the following we solve the primary 4 problem in the GBC porting, and we have sent the 3 RFC page to solve them. And next, Green Tie will introduce the work in Linux.
Hi everyone. All these 13 page sets is that I sent in version 6 vector support page set to the Linux kernel main list. I'm going to talk about the most important 4 pages that I think it. So yeah, as Vincent just mentioned, the U context here is the most important data structure that kernel and the user space, they will share the same data structure. So that kernel would set it, and in signal handler they would read it. And So in this data structure, we can see the general purpose registers here and the floating point register here. And we will need to add the vector register here. But the vector register doesn't look like the general purpose register and the floating point register. They have fixed lengths. The vector register they have they may have different kind of vector lengths. So it is implementation defined. So we have to define a data structure to describe the vector registers. So in here, we define vector structures here that we would save some important CSR here and data P pointer to point to the vector register. And there is a size element here, so we could know all the what kind of vector size is it. Yeah, and in kernel space, data P will be allocated dynamically. And in user space, as Vincent just mentioned, we would need to save all the content to the signal stake. So in here, before we are going to the signal handler, the kernel needs to call the setup C context and to put 3 important arguments like signal number or sig info pointer and the U context pointer. And in the U context, we need to copy all the GPR and the floating point and also the vector register. And according to the layout, so we would copy that vector register to that data structure, so that user will know in user space that they will know how to get all these registers from it. So does the signal return syscall. After the signal handler is done, and it will call a signal return syscall and go back to Linux kernel, and kernel would also according to that data structure to get the register back. Yeah. And in this slide, we'll talk about we also need to add a new type to support for the ptrace. In ptrace, it would send some system code to get the register set. And if they indicate they want to get the vector register set, then we would copy it to the pointer that user space give to the by this system code to give the kernel. And we would copy to user to this user pointer. And in the other way, if user use set register, and we will also copy from user to do that. So we need to add this type and according to that layout to copy it. But the user need to know how big the register size is, and they need to allocate it first. So in this page, we'll talk about the context switch. And we know there is a data structure text structure. And in there is a thread structure. And we will save all the vector context here. So by reference to the floating point context switch mechanism, we would do some partial lazy mechanism for saving or restoring. For example, if the previous task is scheduled out and the S status SRVS means its status is dirty, then we will set all the vector register to memory and set the status to clean. And if the next task it was scheduled in and its status is not off, then we will restore all the vector register from memory and set it to clean. So this might be a partial lazy mechanism. Yeah. So in this conclusion page, that the major feature we have implemented with based on spec version 0.9, and we hope this is very close to version 1.0, so that they might be changed too much. It might not need to change too much. And the features that are still work in progress, that is the kernel mode vector and the kernel mode XOR optimization, and the user mode memory copy, memory set, or string length string compare optimization with the vector instruction. And we also hope that we could optimize the context switch, because the vector register size is really big. So we like to implement the more lazy vector saving restore mechanism for that. And the future work to-do list is native GDB is not support the vector yet. So we would, or someone else you may interested to do that, to port the native GDB to support vector. So here is a reference page, and that's it. Anyone has any questions?
So what's the status of the spec? Like, is it closer to being frozen, or is it being discussed being frozen?
Sorry, Atish, could you repeat that, or maybe type that in the chatting room?
Yeah, the question is basically, when is the vector spec going to be frozen?
Oh, when is the spec going to be frozen? I'm not sure. Maybe very soon, I think.
I think in the maybe related to the OS and the glibs part of the stuff could be part of frozen. I mean, because I think there are still a lot of discussion about vector details, but that's not related to our OS or the glibc stuff. And maybe from our ecosystem view, maybe we could. I mean, we should let the vector basic support in our OS, and let glibc support it, let the OS support it, and then a lot of people could utilize it to implement the vector features. That means they could test, they could run vector. If we don't have Green Time's job, that means we couldn't run vector applications properly.
Yeah, I think the current plan for the vector spec is to try to standardize a much smaller subset of the spec than the entire thing.
Yeah. Just the
define registers and whatnot, so we can start to use it.
Yeah.
I think even that is a ways away.
Yeah. And I think the Green Time's job is very appreciated, and I stopped this work because I hesitated. Oh my God, the vectors change a lot, specification change one by one, and wow, that so I stopped. I scared, and the Green Time pick up it and continue to finish the scalable. That's great. Thank you. Yeah. And I hope we will soon get your features in the kernel and the glibc.
Sure. Also, thank you, Goran. You implement the first version of the vector support, yeah?
No. I just finished my job, because our process have only 100 fixed vector. I just implemented my process version, but you implement the whole Risc-V version. That's great. Yeah.
Thank you. So looks like time is up.
Yeah, I think we're coming into break time.
Okay, thank you.
All right, I guess we got 15 minutes, so I'm gonna try to find some food. Good luck, guys.
Hello?
Hey, Alistair.
Can you hear and see me? Is it working?
Yep. Yep.
Ah,
That's
good.
right? A nice background.
Yeah, I mean, you can't see it, but I have this little thing.
Ah, yeah. Let me switch the slides.
I don't have any slides for this one. If you have the little if you have the thing that I submitted, the little talks, you know, the description, that would work.
Can you make a slide out of it?
No, it's fine. I don't think we need a slide.
I see a share an external video, and I don't see anything. But actually, not having slide fits the perfect agenda. So
Yeah, it's very clumsy, and I didn't have to make slides.
Yeah. Wait for a couple of more minutes.
Alright, I got the description up in front of me.
Yeah, there should be a way to. Oh wait, hold on. There's I think. No, there is no way to share a link. It says upload a presentation, share an external video. Oh, there is an URL. Let me see.
Yeah. Drew just posted it. Yeah, that's it.
Yeah, let me see if I can do that. It says video. Oh no, it has to be a video URL. So
No, that's
you can
fine.
share your screen, I think. Let me.
I'm on a different computer though. And I look at my computer where the conference is. I look like this.
Okay, that's fine.
Okay, it's fine. We don't need anything.
I'll just make you a presenter anyways because you have the next talk as well. So.
Oh, cool. Okay. Oh, am I presenting the slides for the next talk, or are you doing it?
So you own the slides when you're in presenter mode. That little plus at the bottom lets you pick which slides you're showing.
Oh, okay.
If you want, we can swap them over for you. But you go backwards and forwards.
Okay, but can you guys swap them over to the ones I uploaded for the next talk?
Yeah, but we have to boot you out of presenter mode and then put you back in presenter mode.
Okay, that's fine.
And only one person can be in presenter mode at once.
Okay. Should I start now, or give it a few minutes?
I think, given that there was a break, let's wait. Oh, is it exactly? I don't have a clock.
It's exactly 10, right. So
yeah, let's get going then.
I don't think this will take the full half hour though, so we can maybe wait another minute.
All right, okay, we can wait a couple of minutes. I have
give everyone a chance.
Obtained food, but not eaten it, so I'll try to jam as much in my face.
Wait, don't you only eat once a day? Couldn't you just have pushed out the eating to an hour?
I got up super early and drank a bunch of coffee, so it's more than I'm super caffeinated, and less. I'm gonna kind of lose my mind here if I have to sit still for another hour.
Yeah, 6:30. Waking up at 6:30 a.m. doesn't work at all. So.
Yeah, I got up at 5:45 because I wanted to figure out how to do the room. I was worried that I couldn't sort out the presentation stuff, but it went pretty smoothly. Of course.
Yeah, the platform is good, except I couldn't log into my. Initially, the laptop I was logged in, I couldn't turn on the My God video, so I have to switch the laptop. So sometimes it has bugs.
And the notes don't work. The notes keep crashing.
Yeah. So I have now 3 screens, in 2 laptops, one in chat, one the other chat, and then another in notes. So.
Okay. Alright, so I think I'll start. It's 10:02.
Yeah, sure.
Okay. So basically, this talk is not a talk, it's just a discussion. about the Linux RISC-V kernel policy and the plan for accepting patches. Right. So right now the policy is that the kernel will only accept patches from a RISC-V spec that's frozen or ratified. But there's more and more RISC-V specifications or RISC-V extensions that aren't yet frozen, but people are very interested in. So the vector extension and the hypervisor extension are two key examples. Right, they've both been discussed today, but there's no mainline support in Linux for them because the policy is you won't take non-frozen extensions. My computer made noise. Can you still hear me?
Yep.
Okay.
Yeah,
so that's basically the discussion, right? So as a QEMU maintainer, we've been taking draft extensions for a little bit now. We have the hypervisor and the vector extensions are supported, and we've updated the hypervisor extensions and the vector extensions. There's in the next version, patches are on the list. And it doesn't seem to be too much of a problem. We haven't had anyone complain, but we have less users than the Linux kernel does. So this discussion was...
Other issue with QEMU is that multiple versions are not being maintained.
Yeah, so that's part of the policy of the draft extensions is we only maintain the latest, and when the final one comes out, we'll only maintain that to reduce maintenance. So that affects some users, but how many people actually care about the older versions of the hypervisor spec? The vector extension is a little different, but again, there's not that many people caring about the older ones. Anyway, so it's just discussion to talk about that for Linux. Thoughts?
I mean, I assume that you want me to talk here. I don't want to merge draft stuff into Linux because.
But how long can we wait?
Oh, sorry.
No, I was just like, how long can we or should we wait? What if it takes years and years?
I think the problem here is that the specifications take too long to get ratified.
Yes. Yep.
But with just cause, right? Because once they're ratified, they'll go into hardware and then you're stuck with it. So it makes sense it takes a long time.
No,
but
I
think that's where the pain comes from. I don't think that merging stuff into Linux will fix that, and it'll open up a lot of problems, right? Because when the foundation comes out and says, hey, here's this spec, it's going to be compatible, and then they change their minds, we're stuck in Linux land with this old version that we sort of said was compatible, and people started using for stuff. The ABIs start to filter all over the place, and then what do we do?
No, can we use the same QEMU policy? We support only the latest extension until the spec is frozen, and then because that if the spec changes significantly, whoever is the developer will have at least less problem keeping the out-of-tree patches for years, and nobody's able to test those patches except who is developing those patches.
Okay, so now the out-of-tree patches thing. I think clearly it's work to maintain that stuff, right? So I think we've run into this in GCC land as well, bringing those all into one branch. So it's easier to maintain, and there's one place for everybody to look. Seems sensible, but I don't really like having it in Linus's tree, if that makes sense.
So I think there's a huge difference between things that have been built into hardware and things that have not been built into hardware. So the way that we handle SoC platforms in ARM Linux is we make it really easy to add new platforms just because we want SoC manufacturers to submit their code before they even ship a product. But then we also, like if they, one thing that happens sometimes is that then there are no customers, or the product gets canceled before it hits the market, and then we just take it out again. So if there's a case where even something is ABI relevant for people who have this architecture extension, and it gets merged into the kernel, but then nobody ever ships a product with this architecture extension, I don't see a problem with ripping it out again, because yes,
so
it's an
I think
ABI,
there's a
but
difference
no, you're not
between
breaking users.
Vendor stuff and draft stuff. And this is something we like, the GCC discussion roughly ended up here too, where the draft specs tend to be ambiguous, right? That's why they're still in draft, right? And they tend to change. They're moving targets. So if we start merging draft specs, we end up with really one implementation of that spec.
So it's not always the case, right? Like the vector extension, from what I could tell, the 0.9, the latest one, is basically what's going to be in the final one.
But that I have been told that for 5 years. so yes, sure, the policy is that 0.9 is what we're going to do, but like.
So, but it's also.
I believe that.
I think there's also hardware with it, right? There's hardware with the 0.7.1, which is not.
And that's
not
the problem, right? Because.
But if there's hardware with this.
Basically, I think the goal is to discourage hardware that implements only the draft. I mean, really, from a fragmentation point of view, we don't want that. I think there's a difference between these kinds of extensions that have been fully baked and made it through the process versus just platforms. I don't think there's any other major ISA out there that essentially does these kinds of draft, releases before they're really fully baked, and that implementations go into mainline that are expected to cover that. If others, have a different point of view, definitely if there are other architectures that do that, definitely let us know. But the Risc-V architecture is a little different, is that it's not taken care of by a corporation. It's taken care of by this foundation, right?
I think the FMA4 stuff is a good example of how this gets screwy, right?
So that's reasonable, Paul. The problem is, with the Risc-V, the problem is it won't get frozen until there is hardware. So you have to have hardware of a draft extension. So there will be always hardware for the draft extensions. And so we're just saying we won't support them.
So my issue here is that, I agree that the foundation policy has this chicken and egg problem where you have to go build hardware with the draft extension, but we tell you not to build hardware with the draft extension. So what
but hardware could be FPGA, right? I mean, like the main thing is just that it's not purely like a software implementation. It could just be an FPGA implementation.
Yeah, but I guess my point is that I don't think merging the code into Linus's tree solves any of those problems.
No, merging the code into Linus tree solves the problem of not maintaining over every kernel release and testing it. Like at least folks who are interested.
So that's an understandable issue, and I think
that's the issue.
What you want to do here is say, like, we don't want to keep dealing with this stuff, and I can just pick it up in some sort of Risc-V Foundation draft extensions super branch that I deal with. It's a headache, but
But then you have to maintain it across every.
We for a while earlier this year we did, or maybe it was the end of last year, we did maintain a branch for a very brief period called I think it was like the experimental branch, where we merged together all this stuff that for whatever reason wasn't fully baked yet, so that folks kind of had an easy way to test. So certainly we could look at doing that again, and maybe that would be helpful.
I have two other precedents that I would like to mention from ARM. One is on 32-bit ARM, we have something like 5 incompatible floating point instruction sets that people just came up with, and only one or two of them were part of the ARM architecture, and some of them were just invented by a vendor. And we ended
but we're trying to avoid that, right?
That absolutely. It's just trying to give some background. And in the kernel, we ended up supporting them just because hardware is out there and there are users trying to use it. On the contrary, there's an example would be the ILP32 support on 64-bit ARM, where there's a mode to run 32-bit user space on 64-bit only CPUs with a new ABI. And there's a specification for it. Everybody has completely agreed on how it should be done if we want to do it. There was no technical reason to stop us from merging it. The only reason it was never merged was that we agreed that we do not want the ABI fragmentation, and we are better off not having it supported in the kernel, because otherwise people start using it, and we don't want that.
And that's kind of my worry with the draft stuff. Now, I think right now the policy also excludes vendor extensions. I personally think that's going to change at some point. I'm way more worried about supporting real hardware than kind of an ideological purity to the ISA. So I really view that no vendor extensions thing as a lever that we use to get people to play ball with the foundation. And based on how long the specs are taking, I think it's likely we end up having to deal with the vendor stuff at some point in the future on the GC side. What we kind of decided was if a draft gets implemented in hardware and a vendor wants to call that hardware that they're going to support, then that draft is now their extension. You know, if Apple.com builds a vector 0.8 chip, it's not the Risc-V vector extension, it's my vector extension. And then it's my problem to deal with compatibility.
That have happened, yeah. Parma, I'm from the vendor's extension. Maybe you have mentioned. In fact, I have a lot of patch didn't send the Linux tree, but the chip has produced. Because we met a lot of problems, current Linux tree of for the Risc-V didn't support SID, and forced some very strict memory ordering, and that a lot of concurrency issues, and this limitation we needed to make extension to support it, and I have a lot of patches such as SID, such as the support concurrency bit in the page table, and I don't know how to merge it to the Risc-V tree.
Yeah, I know. So I'm more worried about that side of things than the draft extensions, because there's hardware, or there will presumably be hardware at some point. You know, if it's an internal research thing and the chips never show up, I don't really care that much. But at some point we're going to have. Sorry.
So if the chip there, and I think you could consider to merge my pages in the tree. I mean, you know, SID I have mentioned to the Risc-V Foundation, and they don't like the broadcast ones. They want per core per SID core.
Yeah.
But you know.
So I think it's extraordinarily unlikely that anything produced directly by vendor ends up as a Risc-V spec in a fully compatible fashion. So this early stuff is going to go in as vendor extensions. Now, we've said none of that in the kernel. I'm not necessarily ready to change that right now, but we are kind of flirting with changing that in GCC. Maybe we'll see how poorly that goes, if that makes any sense.
Frankly, current Risc-V cannot meet business requirement.
Yeah, I know, that's the problem. And that's, if we had enough of an ISA to build stuff that actually worked, then I'd be fine telling people, no, don't do your custom stuff, do our stuff. But we don't. So your option is not like use the Risc-V standard stuff or make up your own stuff. It's make up your own stuff or build something that doesn't work. And I don't want to tell people just don't use Risc-V. It's just it's silly.
Yeah. So what I would do in your place is to make a huge to do this very different for 32-bit and for 64-bit. So for 64-bit, I think it is absolutely essential to have a stable ABI for everybody that works, so you can have a kernel that works on every possible chip for the future.
Yeah, so one thing I'm 100% not going to change is that any code in the kernel has to be built it has to be buildable in a fashion such that the same kernel runs on all the hardware. That's not changing. So you might be allowed to build kernels that don't run on everybody's hardware, but if the code goes in through my stuff, it's got to be able to build everywhere, and that's true for like anything.
I mean, that's obviously the best way to do it, but for 32-bit, I wouldn't even require that. So if anybody is building a 32-bit product today, chances are nobody's ever going to run the same kernel on that machine as on another Risc-V machine.
Yeah, I mean, I buy that, and that's like we have the no MMU stuff, for example, where the no MMU port currently maintains the constraint that it can be run on multiple systems, which is nonsense because you're not going to do that. But
as long as it's on the same memory address, right?
I guess my issue there is that it's like so far it really hasn't been any extra work to maintain that constraint everywhere, because the difference between 32 and 64 doesn't really filter into the ISA, like the vendor-specific ISA extensions. So with them all being separate things, it's kind of easier to just say everything can be built everywhere. And of course, you can disable stuff if you want to. Yeah.
It also seems unlikely that someone will have vendor-specific extensions for 32-bit for Linux. You know,
that is not just likely, that is actually the current state already. So people have 32-bit cores with vendor extensions.
For Linux? Like Linux capable?
I think that the Andes
it has come stuff. It came to Plumbers to talk about it 2 or 3 years ago. And we said, no, go away. We don't want vendor stuff.
Yep.
Out.
Mix 32-bit and 64-bit together is very hard work for architecture maintainer, I think. Yeah. You needed to deal with the high memory. You needed to deal with some stuff specific for the 32-bit machine. Yeah, that's and now there are a lot of the cost 64-bit machine processors such as A53 or I mean maybe 32 bits is not proper time for now to develop, I think, a new architecture. Yeah, maybe. And a 32-bit focus on the cost, low cost and cost down production. Yeah.
Well, as I mentioned in my kernel summit talk today, which was conflicting with this MC, there's actually a huge market for the low end of 32-bit. So anything just single core, less than 512 megabytes of RAM, which is basically abandoned. And I think that Risc-V will take some of that market.
Is that running Linux though?
Yes, I was only talking about stuff running Linux in my talk. Okay. So there's still tons of systems with all kinds of architectures, and nobody else is using is producing new chips, really, new CPU cores. And I think there's if ARM doesn't do any new cores for that market, then
yeah, I think some of that goes down to how ARM has kind of designed their core lineup, right?
Yep.
I think it's less of a fundamental 32-bit thing, and though if you're trying to replace those systems, you might want to be 32-bit for other reasons, right? But I think unless ARM starts to have more small Linux capable stuff, someone's going to fill that.
This is a great setup for my next talk.
Yeah, so I think 32-bit Risc-V Linux stuff is going to show up. I think we can agree on that. And I think we can all agree that it's not going to be for servers. Seems insane. I mean, people build anything, but yeah.
But I think there's another aspect of this, which is just the maintenance burden for anything that's vendor specific. I mean, certainly it's already challenging to really have good test coverage on a large number of platforms, and I think that would be another concern with accepting anything with vendor extensions. Is ultimately, once it gets into the mainline kernel, it's sort of our collective responsibility to maintain it. The vendor is essentially transferred some of that responsibility to us and to the community, and so that's another reason why I think we have to be careful about this.
It's a big reason why I'm really hesitant to start pulling in vendor stuff, because what do we do with those specs, right? There's all sorts of licensing and lifetime and at least at the Risc-V Foundation, there's a place to go to handle all of that. And if we go outside of that, we open ourselves to all sorts of scary issues.
It wasn't trying to push the vendor thing. We were just talking about drop specs at the start. It's valid now. Please forget it.
You opened a huge can of worms there.
Yeah. So I asked a question, Palmer, and some vendor specific patches like our processors, I will send to you maybe tomorrow or next week, and could you have a review, and then we could consider how to merge it with the mainline Risc-V.
Yeah, I mean, I think you can send them.
And then you will see it.
I'm not
and you will see
convinced I'm going to take vendor extensions yet. I think it's a little premature. I kind of still hope that that things get sorted out at the Risc-V Foundation such that the processes kind of move fast enough that that people can build hardware using Foundation specs. I don't.
So someone just, Dimitri just said that shouldn't the draft extensions go into staging tree and never graduate? And
So-
go to vendor?
Historically, I mean, it'd be fun to hear Greg KH's perspective on that. I think in an ideal situation, staging probably shouldn't even exist. And I don't even remember why he finally agreed to it in the end. But to have a huge expansion of staging, I think that would definitely cause some disturbance. It's kind of like a place where code goes to die, basically.
Particularly the draft stuff is very Risc-V intensive.
In fact, our processor could work with the compatible with the mainline Risc-V tree, but it's with a very low performance. If we want better performance, we will get into his enhanced mode, and this enhanced mode I want to merge it to the mainline, but seems it's couldn't acceptable by the current policy of the Risc-V.
Yeah, I mean, I think sending the patches is okay. It's still against the policy. It'd be nice to see what they are, so we can kind of get a feel for what people are doing. I don't quite know what to do, but I am somewhat worried that we have this kind of coming, massive fragmentation due to the specs going kind of slow, and
So I have a quick question for Guo Ren. So is there a reason why some of those custom extensions, is it possible for Alibaba to work with the foundation to try and standardize them?
First, we follow the Risc-V Foundation specification. This is our policy. But we made some specific problem that we needed to solve immediately, or we won't let our product meet customer requirement. So we needed to and then a lot of specific things happened there. For example, the current Risc-V forced concurrency of the interconnect, but there are a lot of stuff could not deal with that, and we need to let memory mapping with the strong order or not, and that means that's not a concurrency interconnect. So this is one thing, and another thing is SID. SID is a very important feature, but now Risc-V still haven't implementation there, and we implementing first. And I don't know it's the direction of the Risc-V is, but it could let our customer use it and get in a right performance. And a lot of stuff is the catch flash, the detail catch flash, and the performance monitor. And that is so specific things. I think Risc-V maybe defines so much things, so much stuff, and maybe we just focus on the application API, not the whole the hardware system. Yeah, maybe you needed to leave something to the vendors.
But I guess there's nothing that prevents Alibaba from maintaining, or T-Head from maintaining their kernel that they ship to vendors, right? Or to customers, rather.
I don't want to tell her to just go fork.
Exactly.
I don't think we can talk it. We just talk some technical details here, and I talk the policy, and I don't want to talk. I just want to talk some detailed technology things, and we just made problem and meet some performance issues, and we solve it, and let our products could be used, or you cannot be used. That means compatible Risc-V cannot be used.
So why is this not spec worthy if it is improving the performance?
Not specification. I didn't obey the specification. I mean, I just mentioned something that didn't define in the specification.
I think the issue here is that even if the hardware has to get built on timelines that kind of aren't viable if you're trying to get specifications through the Risc-V Foundation process. So things are going to be different between what would eventually be ratified and the first couple rounds of hardware, even if you're trying to play ball. That's kind of my worry.
But for embedded, I think it doesn't really matter so much in that you guys can just have your own, open embedded or whatever distribution. But in the moment it kind of goes into mainline, that's when, you get into these issues of what the Linux distros support and just these broader maintenance issues. And that's, I think, why there's this incentive to work with the foundation to get things standardized.
So I tell you that our process is compatible with the Risc-V specification, but we have another enhanced mode and to make the performance better. And a lot of things is not defined in the current specification. So that is our current status here. And I need your help to direct us how to do next. Maybe we will have the Risc-V better here.
Thanks. We're out of time. Is anyone? I'm the next talk. So does anyone else have anything last word?
Just one quick comment, Alistair, that from a distro standpoint, if it's not in a ratified standard with existing hardware, I'm not interested, because I'm going to have to support that for 10 years.
I think that's reasonable. We're not trying to say, vector extension is draft, therefore Debian has to support it. It just disabled by default, just an option, so we don't have to maintain it as much. People can test it. People who are interested can test it, submit patches, bring up hardware, bring up FPGAs, all that stuff. not shipping it in RHEL or Debian or anything like that. So
exactly, I think the twist is that one of the basically our premise is we will put it in RHEL if it is upstream. So I now have this if Palmer decides to suddenly start accepting things, right? Then I now have this situation where I have a mainline kernel that I have to accept patches for hardware that may not comply with the value or with the standard that's still draft, right? So
yeah, it's kind of I prefer
that's not going to work.
Keep it in a tree.
Yeah, keep it someplace else, right?
Yeah.
So
it's very easy.
It doesn't, right?
Yeah.
I just typed in the chat as well. If I don't see a problem with just merging unredified specs into the kernel, like support for them, as long as it's turned off by default and it's very clear that distros will not be able to turn it on. Like you can make it depend on config expert, which is always disabled in distros. The code can be there, people can look at it, and everybody who reads the code should get the warning that, yes, this will change if the specification changes.
Yep. So I guess how is that different, though, from keeping it in a separate branch?
Separate branches always are a pain to maintain. Somebody has to maintain it. Nobody knows if this is still the current version or if the maintainer has changed and there's now a different tree to look at or whatever. Just if people are actively working on it, put it in mainline. If people stop working on it, take it out of mainline. Just remove the code, but just don't have too many trees. It's my general.
Speaking as somebody who has to review a lot of code, like the churn like of just constantly adding and reviewing the draft spec stuff is definitely more work for me than it would be if we just tossed it in like a separate branch or a separate tree.
Yeah. Well, do whatever is less work for you then. I would do it in the kernel tree. If you think it's less work to do it in a separate tree, then do that. But don't let it stop you from adding it. If we can just disable it, I think. If it's, I don't think the ABI argument is very strong if it's turned off by default and we reserve the right to change it at will, if according to the specification.
Okay. Can someone take back presenter mode and change the slides?
Trying to unmute myself and I hung up. I don't even know if you can hear me.
Yeah, we can hear you.
Cool.
Awesome.
Maybe you can presenter mode yourself?
How do I? Oh yeah, I can do it. How do I?
We'll race. All right, should be good.
Okay, cool. So I'll start straight away because we're a little late. So 32-bit Risc-V port, people have talked about it today. I'm not gonna talk about it too much. I'll skip ahead to the discussion part basically. So for anyone who doesn't know, the Unix epoch is going to overflow with 32-bit time T. That's called the year 2038 problem. And about, I think 2 years ago now, in a Plumbers, it was decided that we would, for Risc-V, just skip the 32-bit time T and just support a 64-bit time T. And that was going to start with the Linux 5.1 kernel. And so that's one of the main reasons that the Risc-V 32-bit port has taken so long. And so you can download the slides and look at this if you're interested. So discussion points. It's pretty much done. All the patches are reviewed. I'm planning on pushing it tomorrow unless something comes up today that will stop me. We'll need the 5.4 kernel and the 5.4 kernel headers because of the new PGID ID type. That's not a big problem. And yeah, lots of benefits of 32-bit ports. Arne talked about it earlier that it's going to be, there'll actually be some market for very low-end 32-bit ports that run Linux. On top of that, FPGAs, it's much smaller to put a 32-bit softcore on an FPGA, like Vex Risc-V. and it's useful for testing things. So does anyone have any thoughts or comments on that before I move on to my first kind of question topic discussion thing?
I have one radical thought, which is I just saw that nothing's stopping you. Like, that was great work. I mean, it's taking much longer than we all expected, but yeah, good work. Even though the most important libc for 32-bit is probably muzzle at this point, not glibc. A muzzle port should probably take you less than a week to get implemented and merged. Now that you've done all the glibc work.
So when you say take you mean take someone else that's not me, because I'm done.
The code is easy to read. You could just do it, and it's literally just a handful of files that you need to implement, and the ABI is already there.
But I think some of the muscle folks are pretty interested in the 32-bit stuff.
Yes, just do it.
Hung up on not having a stable
have someone do it. It's easy. Do it.
Yeah, that is probably true. I think muscle is probably more targeted to that group, but it's still useful to have glibc, as it's still the most commonly used one.
Also, my most exciting feature is that we can now actually run the GCC test suite without a bunch of insanity.
So how many APIs are you going to support in this one? Because I believe that 32-bit probably will have more APIs to support, right? Everybody will. Some may not have floating point, some may. More than 64-bit, like here you'll have more variants, I believe, right?
I was looking at that before. What do we have?
Yeah, so in glibc 64-bit, we
just
support float
two.
and no float.
Yeah.
Should be the same as 32.
Yeah. It's ILP32 and ILP32D.
Yeah, there was some discussion of, F, not D, F, but we decided to just not do that because it wasn't worth the extra ABI. If that makes sense.
Okay, I'm going to move on. We can keep talking about other things. I've just got a few things I wanted to discuss too. So the PLT issue is kind of solved since I put these slides together. There's a glibc test failure where there's a PLT memset call. And basically the question was, what is the plan with the Risc-V call and the Risc-V call PLT? But it seems like there's a BigNewTools patch already sent to fix this up and remove
I think
one
this
of them.
is fixed as of maybe like last night or something.
Yeah. They treat them the same. A BigNewTools patch from Nelson is sent this morning.
And this kind of test failures, in general, if you don't have linker relaxation, then it's not fixable. So the glibc test suite is just a bit overeager in this area. And other targets have to waive similar test failures.
Yeah, the solution to fix the test failure was kind of add a ignore for it.
Yeah, that's okay. I mean, the idea is to prevent certain bugs, but for if libgcc is built outside the glibc tree, then you just can't build it exactly to what the glibc test would expect.
So should we? So the question is, I guess, so this will fall into the BigNewTools 2.36. Is that the next release? Should we just put up with the test failure until that comes out, or should we look at fixing the test failure in glibc by just ignoring the memset PLT problem? That's what the first
that's
link
more of a
was.
Florian question than me, but I'd be fine just if it's fixed in BigNewTools, I'd be fine just leaving it alone in glibc and annotating the test failure when you put the test report up there, and it'll go away.
Okay.
Yeah, sounds reasonable to me.
Okay. Cool. That one was the quick one. This one. So there's a pthread RW lock arch struct, and the Risc-V 64-bit one uses, it looks like this on the left. and it's the same as the AH64 one, which is different to the generic one. The 32-bit one looks like this, which is the generic one. Was there a reason that we used the AH64 style one in the first place, and should we use that for the 32-bit one, or should the 32-bit one use the generic one?
This slide is just a white box for me.
Oh, can anyone else see it?
Yeah, it's visible here.
Okay, I'm gonna turn this thing off and turn it. Oh, here it just popped up. Okay, whatever. I don't know. Let me look for a minute.
So I think it's mostly at you, Palmer. I'm pretty sure you did the first port. So
yeah, and now I have to remember what I was doing. Okay, so
that was a lot of questions in the chat. I can't keep up.
I don't remember. Sorry.
All right. It changes the. I can't remember now. It squeezes it all in more.
I know, and I remember spending a bunch of time doing this. I just don't remember why we had to do it. If that makes any sense. What were we doing?
So the current plan is to use the generic version in 32-bit. If anyone else thinks of a reason not to do that and use the kind of more similar to the Risc-V 64-bit one, let me know.
I mean, this
quickly.
is the GLC that's going to be released, not in like a couple of weeks, but like 6 months,
No,
right?
we have 5 months. Yeah.
Yeah. Okay. All right. So I think the best thing to do is to just like ping the mailing list again and
Lauren?
Try to figure out what I was doing 5 years ago or whenever we did this. Right? Yeah. I don't know.
I think there was what makes it complicated is that the implementation of the RW lock changed. And we had to maintain ABI compatibility with initializers, if I recall correctly. And this is why we have these crude hacks in there.
I think we didn't use the RV64 version. Or sorry, we didn't use the generic version, even though there was one when we did the glibc port the first time around for some reason. It might have been that we just didn't want to toss ABI compatibility that late in the process because some distros had already built against it, and this didn't seem like a scary or a good enough issue to toss binary compatibility, but I don't remember for sure, if that makes sense.
Okay, it's not helpful.
Yeah, I know. Sorry. There's almost certainly some email thread about this somewhere because I definitely spent a bunch of time staring at this thing.
So for the time being, I'm going to keep it generic, and we have 5 months to change it.
Yeah. I don't think there's any like complete non-starter for the generic version.
Oh yeah, the word size one. This is fun too. So 64-bit Risc-V define this word size times 64 compat 32 as 1, which means we use 32-bit times for like the login syscall and the get RU line syscall. We can't set it differently on 32-bit glibc because that would then not allow us to have mixed xlens user space. So the plan is to set it as true for 32-bit, even though we have a 64-bit time T, and then just deal with it like everyone else is going to have to and migrate forwards. Does that sound reasonable?
I mean, it kind of smells like a mistake in our 64-bit port.
It was a mistake in the 64-bit port, but we're stuck with it now. So the only option...
I don't, we can't do anything about it, right? So,
the only option would be that the 32-bit just deviates and we don't support mixed XLAN user spaces, but that seems worse. And then the 64-bit still has to migrate.
Given that we're going to have to deal with this in 64-bit, I think we're better off just keeping them the same and dealing with it once, if that kind of makes sense, for both of them.
Okay. That was the plan there too. Oh yeah. Okay, so I think people have been chatting about this. It's really hard to follow the chat while talking. But basically, so now that we, in a week, let's say we'll have 32-bit glibc support for Risc-V. But now it's not just that. So now we have to do a whole heap of other stuff. So there's a lot of software that's not just glibc that does syscalls. And OpenSSL and BusyBox are two examples that never already been patched. But we need to do that for every other program that does syscalls. So anything that does futexes or time-related syscalls will need to be patched. It'll fail to build for 32-bit Risc-V. So we need something like an OE World build or a Deb Bootstrap or something like that to kind of run through all of the programs we can and slowly fix them and send patches upstream. So if people have if people have spare time, now's a good time to start.
And I think it'd be really nice to have like Debian bootstrapped before we get stuck with the ABI, just sanity sort of thing. But that is a lot of time, so I don't know how we're going to do that.
So there's a list of things that are known to fail for early Linux when they bootstrapped their 64-bit time T on other 32-bit ports with muscle. So you should certainly look at that. I can post the link in the chat.
Oh yeah, can you do that? Is Kem around? Kem seems like a good person to help with this.
Yes. Yeah, I've tried to send a few patches upstream, but they met with some not so much of interest. So I guess is it going to be RV32 specific, or is it going to be like case with glibc?
This will apply to all year 2038 safe 32-bit ports eventually.
Yeah.
Would it help to have? Sorry, go ahead.
Yeah, no, I was saying that are there other architectures kind of changing from to 64-bit time T?
Arc has changed, and ARM is a work in progress.
Okay.
Would it help to have a proper futex system called Rubber? That might be an easier sell to upstreams to clean this up.
The futex one, I think, is just a simple define. You can just define the 64 one as the normal one, or the other way around. I'd have to look at it again.
Yeah, and unless you use the time arguments, then
yeah. And like BusyBox does its own get time or something, I think, because they don't trust the libc one.
Yeah, I think a lot of them were changed, like there were like issues in the applications themselves. I think most of them were like that, where they assumed, the bitness or the length of time T. So I think many of them have already been addressed with the muscle, but we still might have few.
Someone in the chat, someone said, whatever happened to the Linux will never change its syscall ABI. The problem is the old ABI will stop working, so we kind of have to change it.
And also, it's not that we're changing the syscall ABI. We have
There's a new one.
Yeah, like there never was one on RV32.
Yeah.
In theory, there was one, but it didn't actually exist. Right. The issue here is that our generic syscalls don't smell like everyone else's because we have 64-bit time T's on 32-bit systems.
But everyone else will eventually be like this.
For new ABIs,
or they'll stop working.
Yeah. Sorry, Brian?
This has been going on for many years. We got when was that? The OpenAT, the OpenAT system call replaced the Open System call for new architecture. So you have the same problem there. It's just it looks RV32 specific because you're just the first people who encounter these issues.
Yeah, and every time there's a new architecture going in, you've got to go chase around everybody who does syscall stuff.
Yeah. Well, one difference here is that glibc actually tries to handle it differently from the others. Instead of making Risc-V 32 behave the same way as the others will behave, the decision for glibc was to intentionally make it as different as possible, as far as I can tell.
Or presumably every other new arch that goes in would be this flavor. Unless I'm misunderstanding something.
Yes.
Well, there won't be any more 32-bit architectures, sorry. there might still be 64-bit architectures getting merged, but this is the last 32 one.
Yeah, well, sure.
So someone asked, why would you want Linux on RV32? Oh, no, okay, sorry, Jill was answering something. So yeah, someone else, I think today asked about distros. I don't think there's any support from Debian or Fedora or anything to support 32-bit. This will just be a build root, an OpenWRT, Open Embedded, that type of thing. Open Embedded has 32-bit support now with the patches, but eventually it'll be upstream glibc.
I think if someone wants to do Debian, Fedora, whatever, it would be a good thing to do. It does test a different set of things than Open Embedded does.
Yes. Oh, yeah. This is definitely worth doing, but I don't know if they'll ever officially. I think that at least kind of desktop distros are getting rid of 32-bit.
And I think it's unlikely there are serious users, if that kind of makes sense.
Yeah. But anyone doing FPGAs now, you can run upstream glibc. Well, in a week I'll run upstream glibc. So does anyone else have? I think my last one is strace, and this is kind of off the deep end here, but I can't get my strace for 32-bit RISC-V to work, and it hangs on this syscall. So if anyone knows what that is, but otherwise I'm out of slides and discussion points. So if anyone else has anything they want to talk about or add, now's the time.
Thanks for doing this. It was a big problem for a long time. So it's great to have this exceedingly close to done.
Yeah, that's finally gonna get in. So, and now Arnd volunteered to do the muscle port, so we're good there. We can wrap up it. I mean, there's still people chatting in the chat room.
Yeah, with the number of people involved, it might be easier to chat in the chat room than to try to use the audio.
Oh, and Gentoo has 30-bit 2-bit support as well. Oh, but they use muscle, don't they?
No, they don't.
They don't?
No. Muscle is Alpine. They use.
Oh,
muscle.
that's what I was thinking.
Yeah, pretty sure we just had a bunch of out-of-tree stuff in Gentoo land for a while.
So is 5.4 going to be the first kind of like stable API for 32-bit?
No, the Arc has a port already. They used all our generic work we did and snuck in and got their support in first.
Yep. So both glibc and Muzzle actually support running 64-bit time-t on older kernels, and Muzzle has a lot of changes in there to even make all the octals work that I think glibc does not have. So if you want to have certain device drivers like audio support, then you need an even newer kernel. I think 5.6 has all the patches you need for that, or you need the same kind of ioctal emulation that Muzzle has. But most likely the machines that we're interested in would run a newer kernel anyway, or they would not have sound support.
I see.
And we also have, for glibc, we have the really, really old X32 board, which also had a 64-bit time-t. But given the recent number of bug reports that have come in, I don't know how many people have used it until now.
we tried to kill it off, I think 2 years ago, and there were very few reports from users. So some people like to run just GCC under it because it's faster. And there was like 1 or 2 people who actually run a full system, and I just assume they don't report their bugs because there are too many of them.
Now the chat's just gone. They're talking about MMUs.
Yeah, we're
Not
talking
really
about the
related.
K210.
Yeah.
Just talking. I guess there's the chat, like the, not this chat, but that other chat, which might be a good place to keep all this stuff going. There's also some hack rooms and whatnot, but I think we're out of time-ish anyway, so.
Yeah. Okay. So I think we'll wrap up. Anyone move to the other chat?
Yeah, here, it's right here.
Do you want to, are you
Sorry
taking that
for
control?
derailing the chat.
Yeah, I can take
That's
control.
okay.
It doesn't really do a whole lot, though, because I think we're just gonna, I don't actually really know if I'm meant to shut this down or what.
Go ahead and just leave the chat running. We'll go ahead, or just leave the room running. We'll take care of shutting everything down and getting rid of the live stream and everything.
Cool, thanks. Because I don't know how to do that. All right, bye everyone. I guess we've got mailing lists and IRC and all that sort of stuff. So
we're going to save the notes, but also just go ahead and grab and save the shared notes if you want those for your own records as well.
Okay.